Hello everyone, welcome to all of you. Our resource person has joined. So a very hearty welcome to our speaker, Dr. Bhagalpur. We are delighted to have your presence in our STC. Thank you for providing a valuable time for this STC. So I am going to introduce about him. Dr. Behul Soni has been working as an assistant professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, Mainit, Bhopal, India since 2020. Moreover, he was associated with Intel Technology India Private Limited. He received his PhD at BIT Mishra, Ranchi, India in 2018. His research interests include ad hoc and wireless sensor network, IoT, human health monitoring using activity recognition systems, AI and ML. He has contributed many research papers in international peer-reviewed journals and conference proceedings, including one of the top-ranked conferences, that is IES in the above mentioned research areas. So I would like to call Vaibhav Shonishar to deliver his talk. Welcome, sir. Hand it over to you, sir. Please.
Thank you, Dilip sir. Should I start with the presentation? Hello,
Yes, sir.
I'm audible or hello?
Yeah,
Can you
yeah.
please?
Audible, sir. Audible.
Okay, okay. Good afternoon, everyone. Before I start with my presentation, I would like to thank to Dr. Dilip Kumar Chaube, who is working as an assistant professor in the department of CSC at IIIT Bhagalpur. I would like to thank him and the entire CSC department of IIIT Bhagalpur for approaching me for such a meaningful and wonderful short-term course on AI and IoT in biomedical engineering. So, without wasting any time, so let's start with the uh, presentation of today's topic. So today I'm going to present on deep learning based human activity recognition in IOST. So IoT is the subdomain of IoT, which stands for Internet of Healthcare Things. And here we will be focusing on the role of deep learning models or deep learning techniques in the field of human activity recognition. And IoT is one of the application domain where human activity recognition can be applied. So let's start with the basic definition of human activity recognition. So, human activity recognition is a process of automatically identifying and classifying human movements and activities through the use of sensor data. So, these kind of sensors, we can use different type of sensors such as accelerometer, gyroscope, which can be considered as which can be which can be equipped with any wearable devices or smartphone. So nowadays, either we can use any variable devices which can be placed to a particular subject or individual, or we can simply use a smartphone where all these kind of sensors are already there, and the
Sir, your
data
screen
related.
is not visible.
Sorry.
Sir, your
Okay.
screen.
Okay. Let me share the screen first. Sorry about it. Just give me a minute.
Yes.
Uh, just give me a minute. Okay, is it visible now?
Yes, sir.
Okay, so I'm going to restart. I'm going to start over again, right? So today I will be talking about deep learning based human activity recognition in IoT. As I already told, human activity recognition is one of the tasks where we can perform detection or classification kind of objective with the help of deep learning techniques. And IoT is a subdomain of IoT, which also stands for Internet of Healthcare Things. So whenever we are trying to develop any model with the help of IoT devices in the field of healthcare, it can be considered as an application domain. And deep learning, we can say deep learning is nowadays can be applied in almost every kind of problems, right? So human activity recognition with variable sensors will be will be discussed in today's presentation. So the slides are changing. Hello.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So let's start with the basic definition of human activity recognition. So human activity recognition is nothing but the process of automatically identifying and classifying human movements through sensor data. And here we can use different type of sensors such as accelerometer, gyroscope, which can be the part of wearable devices or smartphones. So there are different applications where HAR can be used. The first and very useful, like popular application is healthcare. So health HAR can be used to monitor the physical activity and health status of any individual with chronic disease such as Parkinson disease, diabetes, heart disease, etc. So like here, what we can do, we can simply place some variable devices to the subject and we can keep tracking their movement, right? And depending on the movement, we will be able to detect any unpredictable behavior of the patient. So we can say by tracking their movements, healthcare providers can identify changes in their behavior and adjust their treatment plans accordingly. So wearable devices is the only thing we need in order to track their movement. Another application is sports and fitness. So HAR can be used to track and analyze the movements of any athlete and fitness enthusiast. This can help their optimize their training out routine and prevent injuries. So nowadays, as you can see, now suppose if I want to check the perfect bowling action, right? So what we can do, we can place different devices in the different portion of the arm, and we can guide any particular bowler, a batsman, in order to achieve the best possible action to deliver any ball in a perfect way. So like HAR is again another application where sports related kind of activities can be monitored, and depending on the collected data, we can train any particular athlete in a particular field. Security is another application where it can be used to detect suspicious behavior such as trespassing, theft, and vandalism. It can also be used to monitor public spaces such as airports, train stations, and shopping malls. But in most of the cases, for security kind of application, we will need camera type of devices. So in coming slides, we will be discussing different type of HAR. The first type of HAR is called variable sensor based HAR. Another type of HAR is called vision based HAR. So security is one of the application for vision based HAR where we can place some sort of camera in a particular premise and we can detect any suspicious like intrusion of any particular unauthorized person, right? Another application of HAR is like robotics. So it can also be used to enable robots to understand and interact with humans more effectively. So nowadays, as you can see, we have already designed or developed so many robots which can work, run, or perform just like a human being. So here we can train any particular robot which can start mimicking any human being activities. So HAR is also one of the major advantage which it can offer in the field of robotics. So there are different subdomains of HAR which can be used to design any particular robot which are somehow inspired by any human being related activities. Another application is gaming. So it can use to create more immersive and interactive gaming experience. And nowadays, as like VR techniques are there. We can choose our own person or entity, right, in any particular gaming, right? So here the player itself can perform its own activity to actively to be more interactive in any gaming kind of applications. Another application is smartphones. So it can be used to automate various tasks in the home, such as turning off lights, adjusting the thermostat based on the occupant's movement and behavior. So now suppose if there is a sensor which can detect any particular kind of activity, human activity within the room. So whenever any person is leaving the room, the smart home will directly turn off the light and other kind of devices. and whenever you get into the room, it will automatically be turning on all the devices in that particular room. So through the sensor, we can detect any particular kind of activity in that particular premise. So human activities, in summary, we can say human activity recognition is an important area of research in human behavior analysis and human computer interaction. So this lecture will present the HR methods, uniqueness, advantages, and their limitations. Further, this presentation will also discuss about classification and evaluation procedure and discuss publicly available data set for mobile sensor human activity recognition. So I will be considering some data set that you can start with if you are interested to work on this particular domain. So let's continue from here. This is the next slide. Researchers have proposed various HER systems aimed at translating measurements from smartphones into various types of physical activity. Recently, as deep learning has demonstrated like effectiveness in various areas, plenty of deep learning models have been already investigated to address the challenges in activity recognition. So as you can see, there are different problem statement you can start working on. So the most common problem statement is classification. So in a particular data set, there will be a set of activities like running, walking, jogging, moving up, moving down, jumping. So there could be different labels in a particular data set, and you will be able to classify, or you will be able to identify any particular category of the action. So classification is one of the most common problem statement in HER. Another known problem statement is fault detection and prevention. So there is a possibility by tracing by looking into the data, there will be a possibility where we can identify the possibility of any fault. So whenever we are able to detect any fault, we can also develop a system which can enable us to detect the possibility of falling and preventing from it. So it can be useful in various healthcare related diseases such as Parkinson's disease, which can be useful for elderly people, and we can design a system which can send an alert message to a particular person whenever there is a possibility of fall. So there are two known techniques, problem statement of human activity recognition. The first one is classification, and another one is detection of any particular possibility of fall. Now, so as I already told, the HER is broadly classified into two categories. The first one is vision-based HER, another one is sensor-based HER. So each approach has its own advantages and disadvantages, and the choice of which to use depends on the specific application and context. So it totally depends with which particular type of data set you want to start with. If you're considering any time series data set, you can start with sensor-based human activity recognition. And if you are good at imagery data set, or if you have already started working on object detection, segmentation, or imagery data set of imagery data set based problem statement, you can start with vision-based HER. So they have their own advantages and disadvantages that will be discussed here. So sensor-based HER is comparatively less invasive and less expensive than video-based HER, as it requires only small sensors which can be attached to the body or embedded in wearable devices. On the other side, video-based HER uses cameras to capture detailed visual information. So hence, it will be making it more accurate and reliable than sensor-based HER, because the data we are going to collect through video-based camera will be even better. We will be having detailed information captured from the cameras. However, video-based HER also requires more processing power and storage space than sensor-based HER, because whenever we are considering an image data set, the processing power will be more. And when we have the larger data set, it will also need more storage space. So the computation of deep learning somehow depends on the size of the data set, right? So here the variable sensor data set will be needing less computation power. So if there is any limitation of GPU server at your end, right? You can start with sensor-based data HAR. If you're trying to use platforms such as Google Colab or your own laptop. But suppose if you have GPU server at your institute, you can also start with video-based HAR because there is no such limitation of GPUs, right? There's also one more disadvantage or drawback of video-based HAR, that it may raise privacy concerns when used for monitoring individuals in public spaces. Because whenever we are interested taking input or data from any particular person or individual, we have to take the consent from him, right? So in summary, the choice between sensor-based and video-based HAR depends on the specific application and the trade-off between accuracy, cost, privacy, convenience, etc. In some cases, hybrid approach that combines both sensor and video data may be the most effective solution. So their number of data sets are publicly available. Some are totally based on the variable sensor database. Some are completely based on the camera-based sensor. And there are also some data set which have the combination of both, where they have provided vision-based as well as sensor-based entries. So there is a possibility where we can start with some hybrid HAR scheme where the data set can be captured by both kind of devices, camera as well as variable sensors. So this is the broad classification of HAR. Now, as you can see, the most common used sensors are accelerometer, gyroscope, and magnetometer. Here, as you can see, the figure, the number of sensors available with the smartphone. So there are two possibilities. Either we can equip any particular variable sensor or variable device equipped with various sensors on the body of the person, or we can simply use a smartphone which is already equipped with various sensors to collect these kind of sensors. So as you can see, here's a list of sensors equipped available with a smartphone or any mobile devices. But out of them, only few of them will be required for collecting information, like accelerometer, gyroscope, magnetometer, GPS, and many more. But here, most of the times, accelerometer, gyroscope, and magnetometer will be sufficient enough to capture all required entries from the data from the smartphone. So the accelerometer is mainly used for measuring the acceleration of an object, which can be used to track movement and motion. There's another sensor which is called gyroscope, and it is mainly used to measure the rotation and orientation of an object, which can be used to detect changes in position and movement. Third one is magnetometer, and it is mainly used to measure the strength and direction of magnetic fields, which can be used to determine orientation and position related to the Earth's magnetic field. So this particular sensor will be more useful in case of problem statements such as fault detection. So here are like push recovery system. So here this particular type of sensor will be more useful in the field of robotics, where we want to start working on push recovery system. So this kind of sensor, the data recorded by this particular sensor will be more useful. There is also one unit which is called IMU. Sometimes it is also called inertial measurement unit, and it combines multiple sensors such as the above mentioned sensors and many others in order to provide a more complete picture of movement and orientation. So instead of considering different sensor, we can simply buy a IMU sensor, which consists of various required sensor to perform the same tasks. So overall, the choice of sensor somehow depends on the specific application and the types of movement and activities that need to be detected and classified. So while discussing about these sensors, I already mentioned what kind of sensor will be required and why. Okay, and the figure also shows the overview of standard smartphone sensors, right? If you have any doubt, you can ask any question any moment. Okay, so this diagram shows the overall process of HAR. So the process of HAR typically involves collecting sensor data from a variable device or a smartphone, pre-processing the data to remove noise and artifacts, then extracting features from data, and then using any machine learning or deep learning models to classify the activities based on the extracted feature. To the left, as you can see, are the sensors that are sources of the data required to recognize activity. So the left portion shows the visualization of the data collected from these sensors, whereas to the right are activities of daily living that are recognized by the activities recognition chain. So as you can see, there is an activity recognition system which needs input from the data such as gyroscope, accelerometer, magnetometer, and at the right hand side, as you can see, we will be able to like classify any particular kind of activity. So suppose if any person is going up through the staircases, that particular kind of activity can be identified through the classification based model, right? So here's the standard procedure of activity recognition in a detailed way. So as you can see, either we can use any variable device equipped with accelerometer, gyroscope, or magnetometer, or we can consider the data collected by from these sensors, which are the part of any smartphone device. So the smartphone device can be placed anywhere in the body or on the body of the person. So it can be placed in the pocket, or we can use the wristwatch. It can be placed at some other position, right, of the human being. So you can find different data set which has been considered. Those have been considered different placement position of a body on a body of a person, right? So, and the third one shows the raw data collected from these sensors. So for different activities, there will be different visualization of the data. So as you know, so whenever we are collecting an information from any sensor data, so data cannot directly be fed to the model. They always need to be pre-processed because there's a presence of noise and any other problems. So the data pre-processing is always required. So I will be discussing various steps one by one. The first one is data collection, which is nothing but the first step of HER, where we will be collecting data from sensors, all the sensors that I already mentioned, right? The next is data pre-processing. So the collected data needs to be pre-processed before it can be used for training a deep learning model. So this step involves cleaning the data, removing any noise, normalizing the data to ensure that it has a consistent scale. So these are some standard techniques or steps to be followed as part of data pre-processing. The first one is cleaning the data, removing any noise, or performing normalization. Right? Later on, the data can be fed to the model. Now, suppose if there is a publicly collected data, so in that case, we don't have to perform data labeling. But suppose if you are trying to collect your own data, data labeling will be required. But at the initial stage, the data labeling will not be required as long as you are not working on collecting your own data set, right? So the next step will be what? Model selection. So here we can consider the list of deep learning models or machine learning models as classification model. So the most commonly used deep learning models are such as CNN, RNN, LSTM, BiLSTM, GRU, BiGRU, lightweights. There are some lightweight models based on CNN, such as dilated CNN, temporal convolution network, right? So all those deep learning models are more popular in the field of HER because they work better for time series data set. Once the models are selected, we can go for training. So the selected model is trained using the pre-processed data. The training process involves optimizing the model parameter to minimize the loss function, which measures the differences between predicted and actual activity level. So whenever we have already said, whenever we select any particular model, the optimization is always required. So we have to find out the better combination of hyperparameters. So there are a number of parameters we can consider for tuning the model, such as kernel size, loss function, uh, learning rate, right? So all these hyperparameters can be considered at the time of training any particular model, because we are always interested to consider model which is highly optimized. So if you're not able to run your model for different learning rate, different kernel size, or different optimizers, so here you can use some optimization technique which are also popular in machine learning techniques. So there are some optimization techniques such as grid search, random search, Bayesian, hyperband. So these kind of optimization technique can be used to select better combination of kernel size, learning rate, and other hyperparameters. Otherwise, you can run the model for different possible combination, and out of them you can consider a combination for which you are getting the best possible result. And once the model is trained, the next step will be what? Model evaluation. So once the model is trained, it needs to be evaluated on a separate validation set. So here, whenever we consider any data set, it will always be divided into two parts. The first part is the training part, training data set. Another one is the testing data set. And most of the time, the ratio will be like 80-20 or 70-30 for training and testing data set respectively. Further, the testing data set can again be divided into two parts, validation and testing, right? So here the 70% of the data will be used for training, while the remaining 30 or 20% of the data will be used for testing or validating the outcome, right? So we will be checking the performance by considering the testing data set. And here the number of parameters can be used, performance parameters can be used for further evaluating the performance of the model. And these these performance metrics are such as accuracy, precision, recall, F1 score, and many others, right? But these are some popular performance metrics you can consider for validating the performance of any deep learning model. So here in this presentation, I will also be considering some commonly used deep learning model that you can start with. So you can find number of papers which are based on these models, right? So there is a possibility, if you are interested working in this particular domain, you can start working with these kind of models. The first one is RNN. So CNN. So most of the time CNN is known model which is very popular in image based data set, but CNN can also be used for time series data set. Another type of model which is called RNN. So RNN has some limitation or what you can say drawbacks. So RNN, instead of RNN, we can consider either LSTM or GRU. So there is a possibility where CNN can be used for extracting temporal features, while LSTM or GRU can be used for considering long-term dependencies. So in most of the times, the combination of CNN with LSTM and GRU is preferred, where CNN can be used for considering temporal features. On the other side, LSTM and GRU can be used as relation network, which is mainly used for considering long-term dependencies between features. So I will be giving the advantages of LSTM and GRU over RNN, and I will be discussing the key points of LSTM and GRU. There are also the variation of LSTM known as BiLSTM and BiGRU. I will be giving the basic idea of these variations or generalized version of LSTM and BiGRU. So RNN has some problem with vanishing gradients, which means that they struggle to remember information from earlier steps in the sequence. So when vanishing gradient is one of the most common problem with RNN. So LSTM or GRU can be used. So LSTM actually is able to solve this particular problem by introducing a memory cell. So here, as you can, I also mentioned some figures. These are the block diagram of the block diagram of RNN, LSTM, and GRU. So I also gave the block diagram for BiLSTM, and just like BiLSTM, there could also be a block diagram of GRU, right? But these are some commonly used models that those are very popular in the field of for performing the same task. So I already mentioned LSTM is able to handle the problem of gradient descent, right? There's another advantage of LSTM over RNN, and it is ability to remember long-term dependencies in the input sequence. There is another variation of LSTM, which is known as bidirectional LSTM, which is a type of neural network that is similar to LSTM but can take input account both past and future context in the input sequence. So here, biLSTM is nothing but consists of two LSTM layers, one processing the input sequence in a forward direction and the another one is in backward direction. So by processing the sequence in both directions, biLSTM can capture dependencies between the current time step and both past and future time steps. So here, the long-term Sumedha, is there any doubt? So if you have any doubt, you can ask any query at the end of the presentation. Okay. Okay. So just like LSTM, GRU can be preferred over RNN, and GRU is known as gated recurrent unit, which is a specific type of RNN that have a gating mechanism similar to LSTM and allowing them to selectively retain and forward information over time. So there is a like another variation of RNN. LSTM performs better in most of the times, but GRU can also be considered if you are looking for some more compression efficient performance. So there are some advantages of GRU over RNN or other models. The first one is fewer parameters. So GRU needs fewer parameters than RNN, which makes them more computationally efficient and faster to train. So sometimes if you have any doubt, if you have an option to select LSTM and GRU, you can consider both the models. And if GRU is perform as good as LSTM, you can go for GRU because the computation time and power will be less in case of GRU. So better at handling vanishing gradient. As I already told, vanishing gradient is a major problem with RNN, which can be solved in both LSTM and GRU. So there will not be any issue of vanishing gradient in GRU. So there is a possibility where it can also perform better for some specific type of application. So like sometimes you will be having an option to consider GRU, by GRU, LSTM or by GRU, right? So just like by LSTM, by GRU also consists of two GRU layers, one for processing the input sequence in a forward direction and the other one in a backward direction. So by processing the sequence in both directions, again, BiGRU can also capture dependencies between the current time step and both past and future time steps. So based on this, the main advantage of BiGRU over GRU is ability to capture bidirectional dependencies in the input sequence, just like LSTM, right? So there is another variation of GRU, right? So again, there is a chain of GRU in forward direction and there is one more chain in backward direction. So if you are able to considering better capturing of long-term dependencies, the computation power will also be more. So whenever we are considering BiGRU or BiLSTM with accuracy, the computation power will also be increased. Okay. So here I already mentioned the block diagram of RNN, LSTM, GRU, and BiLSTM. And just like that, you can also download or find out the block diagram of BiGRU. Any doubt so far? Okay. Shall I continue? So these are some popularly known data set you can start with. So you can find various resources and source codes for wisdom, UCHR, opportunity, M2, UTD, MHAD, HHAR. So there are some known data set you can start with. You can find various resources and study material as well as the source code for these. Some of these standard data set like wisdom and UCHR and opportunity as well. So as you can see, so there is a column, data set, context, subject, activity, sensor type, challenges. So here, as you can see, wisdom has considered various daily living activities. So they have considered 29, 30, and 4 subjects respectively in order to capture data. And for number of activities, Wisdom has considered 6 different activities. Just like Wisdom, UCHR has also considered 6 different activities. On the other side, Obsidian dataset has considered 9 different kind of activities. So here we need to identify one out of 6 activities in Wisdom and UCHR. On the other side, in Opportunity, we have to identify one of 9 available activities. So the type of sensors have also been mentioned. So here they have considered only the variables type of sensor for Wisdom, UCHR, and other kind of data set. And they have also mentioned some kind of challenges like class imbalance. So whenever there is what do you mean by class imbalance? Anyone who can explain the idea of class imbalancing? Anyone?
Sir, I think, sir, if one class has the representation of, let's say, if there are 2 class X1 and X2, the representation of one is more than other.
Right. So suppose if I consider Wisdom data set here. So as you can see for downstairs, so most of the information connected for downstairs is more, right? Sitting. So this is for sitting. So almost 39% of the information is just for sitting. So here there is a possibility of class imbalance, where some of the classes completely dominates other classes, right? Here as you can see, there's very less amount of information collected as walking. So it is just 4.4. But in case of UCHR and mHealth, the first one is Wisdom, another one is UCHR, and the third one is mHealth. So there's no such problem of class imbalancing in case of UCHR and mHealth. But as you can see, the amount of information collected for different classes are almost equal. So whenever we are considering the same amount of information for different number of classes, right, it will be balanced. But suppose if there is lot of information only for one particular kind of class, it will be called class imbalance. And you can also consider some balancing technique in order to handle the problem of class imbalancing. So it totally depends on the data set whether you need to apply any balancing technique before considering that particular data set or not. So some sort of balancing technique can be used for Wisdom type of data set before feeding it to the model. Okay, is the doubt clear? Like, is it clear? So here is the representation of different possible data set. So I mentioned these 3 data set: Wisdom, UCHR, and mHealth. And they also mentioned the type of the sensor they use for collecting information. A represents accelerometer, gyroscope, G represents gyroscope, M represents magnetometer. Some other type of sensor are also there. So the total number of activities like 18, right? In case of Wisdom, it is actually 6. As you can see, there's 6 different activities for Wisdom, 6 different activities for UCHR, and 10 plus activities for mHealth, right? So there is a typo over here, right? Only there are 6 different activities for what Wisdom data set, right? And they also mention the total number of subjects like 51, 30, and 10 for all these data sets respectively. And they also mentioned the frequency, sampling frequency, and sampling frequency can also be adjusted as the part of pre-processing, right? So where we can reduce the amount of information that can be fed to the model. So by adjusting the sampling frequency can also be the part of the pre-processing that you can consider before considering any particular model. Okay. So there are a number of parameters, like they have mentioned various possible ways to collect information for these kind of data set. And you can also find a lot of resources for these known techniques, data set. The most common data sets are Wisdom and UCHR. Okay. Now, metrics for performance evaluation. So most of the time, like as you already aware of, like we need to evaluate the model based on some performance metrics. So here, the popularly known performance evaluation metrics are confusion metrics, accuracy, average score, recall, precision, and ROC curve. So ROC curve can be used somewhere depending on the requirement. Otherwise, accuracy, even score, recall, and precision will be sufficient enough. A part of that, you can also consider various hyperparameters, where we can find or determine the impact of various parameters whenever they are being changed, whenever the value of those parameters are being changed. So let's continue from here. So the first one is confusion matrix. So confusion matrix is nothing but a table that summarizes the classification results of a model. So it shows the number of true positive, false positive, true negative, and false negative. So it can be used to calculate other classification metrics such as precision, recall, and F1 score. So if the confusion matrix value, the confusion matrix is there, you can simply calculate the value of precision, recall, and F1 score. Another parameter is accuracy. So the accuracy is the most used performance metric for the evolution of the classification performance. According to the confusion matrix showed in the previous slide, accuracy is defined as follows. The equation is given as you can see. So it is the ratio of the number of correctly classified sample to the total number of samples. So by putting the value of TP, TN, TN, FP, FN, and TP, you will be able to determine the value of accuracy. And nowadays, for most of the data set, the accuracy is almost 98 to 99% of accuracy, right? So nowadays, you can consider some data set for which the accuracy is almost around 100%, and for some data set, it is still close to 95%. So it totally depends which particular data set you are going to consider for the same task. So the next metric is F1 score, which combines the precision and recall of a classifier into a single metric. So by taking their harmonic mean. So it is again a commonly used metric for imbalanced data, where the number of samples in each class is significantly different. So nowadays, in most of the papers, F1 score is also a known performance matrix, which is being used. Just give me a minute. Okay, which is being used as one of the known performance metrics. So nowadays, you can find number of data set where there is a problem of class imbalancing. So accuracy might not be enough. You can also consider F1 score as your result, right? So accuracy as well as F1 score are two more popular performance metrics in order to evaluate any particular model. The third one is recall. So recall is also called sensitivity or true positive rate sometimes. So it is mainly used to calculate the number of correct positive predictions divided by the total number of positives. So it is mainly used to measure how well a model can identify positive samples. So here the best possible value corresponds to 1 and the worst to 0. So if the value is 1, it is the best possible value, and if it is 0, it is the worst possible situation. The next metric is precision. It is also called positive predictive value and can be calculated as the number of correct positive predictions divided by the total number of positive predictions. So it is mainly used to measure how often a model correctly predicts positive samples. And again, the best value is 1 and the worst value is 0. ROC is another curve, right? Another performance matrix that you can consider. And most of the times, the value will be in the ranging from 1 to 0.5, right? So here, there is an example of confusion matrix, as you can see. And we design some model by considering wisdom data set. Nowadays, we need to consider 3 to 5 different data set for a proposed model, and we need to check the performance of the proposed model. So as you can see here, I'm considering, as I'm considering 6 different activities for wisdom data set, there is a matrix of 6 cross 6, right? And this diagram shows the confusion matrix generated after applying any particular deep learning model for wisdom data set. Okay, so nowadays there's also there's one more plot you can consider, which is called accuracy or loss curve. So whenever you consider accuracy or loss curve, it shows whether the model is affected by the possibility of overfitting or underfitting. So whenever there is a possibility of overfitting or underfitting, they are needed to be handled by considering hyperparameter tuning. So hyperparameters such as kernel size, learning rate, optimizer can be considered to tune the model. So by looking at the accuracy or loss curve, you will be able to see whether the model is working fine by increasing the number of epochs or not, right? So accuracy and loss curves are another important performance metrics to evaluate the performance of the model. So the accuracy can still be 99 or 95, but by looking at the accuracy and loss curve, you can identify the possibility of overfitting or underfitting. So whenever you find any possibility of overfitting, underfitting, you can use some particular, you can take some particular approach to address those problems. So somehow the accuracy can still be increased. But suppose if you are seeing very smooth graph for accuracy and loss curve, and there is no such possibility of overfitting or underfitting, you can consider the final result as a final output. Okay. So there are some challenges like feature restriction, annotation, class imbalance, distribution discrimination, and there are many other challenges of HR depending on the problem statement you are working on, right? So these challenges can vary depending on the stage problem statement you're working on, right? But most of the cases, the accuracy is the main concern. Apart of that, nowadays, if you have heard of predicted learning, where we want to train our model on different devices independently, where we don't have to collect data from different devices, but we can use their training input just for training the model, right? So here, lightweight deep learning based models have become very popular, and we can use some editions of CNN and other models such as dilated CNN and TCN, known as temporal convolution network. And these models needs less computation power compared to CNN. So CNN is one of the known model which is mainly used in order to collect temporal features. So instead of CNN, we can use temporal convolution layer network or dilated CNN, which is another generalized version of CNN, which needs less computation power for the same task. So here, the proposed model will be needing less computation power, and whenever it needs less computation power, the output can also be determined in less with less time, right? So I mentioned few websites, URLs, where you can find out the implementation of various HR systems with deep learning techniques. So as you can see, there are some resources where those you can consider if you are really interested working on this particular area, right? So here are the list of references I consider for preparing the PPT, right? So if you have any doubt or if you have any question, you can ask. Dilip sir?
Yes, sir. Yes, sir.
Yeah.
Please have some question. You may ask, sir.
Sir, I have one question.
Yes, please. So
Sir, actually, as per my understanding, how can we transfer this learning to some other some other field? Is it possible we can transfer this learning to some other field?
I didn't get your question. What do you mean by transferring learning to some other field?
Means for transfer learning. There is some concept called transfer learning.
So transfer learning is another technique, right? Is another like domain. So transfer learning, transformer can be used like as deep learning model. So I don't think it is directly related to transfer learning.
I mean the same concept where we are recognizing the human activity. Can it be applied to some other domain for the if we
see,
are
obviously,
the
see. So
data?
there's some standard deep learning model which can be used for different some particular type of data set. So if there is time series data set and if there is a problem statement like classification, So some known techniques will be some known deep learning based model will be used. And if you are changing your direction, if you're changing your problem statement, again you will be changing your deep learning models that you will be selecting. Just like that, you can use some attention mechanism. So attention mechanism is another extension which will be focusing on some important features, right? So these are some extension on top of these deep learning techniques. So you are still free to use any particular technique that can be considered as add-on techniques. So just suppose if you are considering attention techniques, right? So attention can also be integrated with LSTM, BiLSTM, and CNN. So just like that, any techniques can be the part of this particular kind of problem statement.
Okay, sir. My concern was, for example, if we want to capture some activity happening in some forest and all, if some
Now,
animals are moving. So my question was directed towards that. Can this model be
obviously,
applied to that domain also?
so most of the times, what happens? Suppose if you are going to select any particular application, right? So you will be considering data set which have been collected in that particular way, right? So here I'm considering this particular kind of application where we are trying to identify different particular activity, not whether there is a person moving in that particular premise or not, right? So at that time you have to select any some different data set. Suppose if I'm considering wild animals, right? So in that case you can find out different data set which will be able to collect detect movement of different animals. So there you can detect whether the animal is tiger, just cow, or some other kind of animal, right? So here at that point, there will be two possibilities. You can also differentiate between the movement of any tiger or any cow, right? So obviously the movement pattern for different animals will be different. So sometimes you can use some sensor-based data set, but most of the times you will be needing a camera type of devices because we can not really equip these sensors to those animals, right? So by applying camera, then training a model which will be able to detect the movement. First of all, we have to detect whether there is an animal or not. Once it is there, we have to identify, okay, what type of animal is there. So you have to consider that data set which has already been trained for detecting different type of animals in a particular premise. Okay.
Okay, sir. Actually, I have seen some application in
Correct.
forest area.
Mm-hmm.
Some people used to do timber theft. So they used to put some sensors and they used to extract data. So I was just thinking if you can extend
Obviously,
this.
see, it's a like there are number of application, right? And there are
Mhm.
number of data sets available. So no one can work on each and every aspect.
Mhm.
So like suppose if I'm working on this particular domain, I'm more confident in this particular data set only, right? These type of data set. But I'm not really sure whether this kind of input or this kind of learning can be transferred to some other field or not. So it totally depends on the domain you're working on.
Yeah, right, sir. Right.
Okay.
Thank you.
Okay. Any other doubt?
So is there anyone who is also curious to ask question? Okay. So thank you, sir, for taking the time to share knowledge with us. Your presentation on deep learning-based human activity recognition in IoT was incredibly informative. You informed us about human activity recognition, its practical applications, categories of deep learning in sensor-based human activity recognition, and its classification. You made us aware of a detailed overview of standard smartphone sensors along with their use cases. Understanding the human activity recognition process is made much easier by use of visual aids. What are deep learning models for sensor-based HAR, such as CNN, RNN, and others, and which is superior in terms of performance? You discuss the metrics for performance evaluation and how they are evaluated. Brief discussions of the challenges in human activity recognition. I sincerely want to thank you once again more, sir, for your contribution to this STC. Thank you very much, sir.
Thank you so much, Dilip sir. Thank you so much. Shall I leave, sir?
Yes, sir, you may leave it.
Okay, thank you.
So I think our next resource person is also online. Jiten sir has joined, sir, I think. Okay, so just take break for 5 minutes. I'm calling to him. If- So you may also start. Okay. So our resource person is joined. Jiten sir. Yes, yes, sir. Good afternoon, sir.
Good afternoon, sir. Good afternoon.
Yeah, hearty welcome to you, sir. We are delighted to have your presence in our STC. Thank you for providing your valuable time for this STC. I'm going to introduce about our resource person. So, Dr. Jiten Kumar is the Associate Professor of Statistics and Statistical Science in the Department of Mathematics, School of Advanced Sciences, Vellore Institute of Technology, Vellore, Tamil Nadu, India. He has he is having over 22 years of experience in academics and over 5 years in industry, like Pro Ferry Technology, Gurugram, DataNet India Private Limited, New Delhi, CESC Private Limited, New Delhi, Bioinformatics Institute of India, Noida, Keshe Pharmaceutical Private Limited, Bhiwadi, Rajasthan, as consultant technical analyst. He had served MIT University, Noida for 13 years, from January 13, 2006 to November 27, 2018, including MIT University, Dubai campus. He is the former HOD of Department of Statistics, MIT University, Noida, and had founded and established the Department of Statistics in MIT University, Noida. Dr. Jiten Kumar is having over 20 years of academics, 5 years of industry, and over 9 years of post PhD research experience. Dr. Kumar has served almost 13 years in MIT University, Uttar Pradesh, Noida. Before joining Vellore Institute of Technology, Vellore on November 13, 2018, presently, he has been the associate professor in statistics and statistical data sciences and analytics. And his core research area are the following: statistics applied and industrial, data science and analytics, multivariate data analysis, econometrics and time series modeling, machine learning, modeling and simulation, biomedical statistics, technical demography. Dr. Kumar has authored and co-authored few books besides having various national and international research papers to his credit. He is having a wide array of experience acquired through his passion for research, academics, projects, training program, statistical consulting, and ability to excel with functional variation. His strength is practical domain knowledge and application oriented skill. Said he has been a member of many editorial boards of reputed journals and regularly involved in review of book chapters, research articles, case studies, curriculum design, etc. He has guided over 150 student dissertation and helped many research scholars towards their thesis work. Dr. Kumar is presently the lifetime member of various national and international organizations, associations, and other scientific bodies, societies of review. He has been publishing good quality research papers in reputable journals and conferences at national and international level. He is having a wide experience in academic research, academic administrations, and industry interaction. His interest lies in organizing, participating, and contributing to the conferences, symposium, workshop, seminar, guest lecture, invited talks, training programs, keynote speaker, and various other academic events like uh, coordinator of examination, program coordination, course review, member admission board, member faculty recruitment panel, member AAB, area advisory board, member DRC, department.
Dilip sir, make it brief. That's
Yes.
all good, kind enough.
Okay, sir, over a period of time during his career, he has continuously been involved in statistical consulting and various funded projects at national and international level. So, welcome, sir. I would like to request you to deliver our talk and hand it over to you, sir. Please, sir.
Thank you so much, sir. Am I audible, Dilip sir?
Yes, sir. Audio, sir.
Very nice, very nice. So, just I would like to share my slide. Slide is visible that side, sir?
Yes, sir. Visible, sir.
Okay, okay. So, let me start my session today on this opportunity of delivering the short-term course on artificial intelligence and IoT in biomedical engineering at Triple IT Bhagalpur. And my session is a little different because as I am going through the various sessions, most of the audience is having variety of diverse topics where different sort of inputs are there. Uh, Before starting the session, I would like to express my thanks to everyone besides these wonderful programs, initiatives, and organizing, particularly the director, Triple IT Bhagalpur, professor, highly respectable person, and renowned academician, uh, Dr. Arvind Chaube sir, and the motivation behind all those things, uh, guiding the Dilip sir to coordinate this program very efficiently, as myself is attending much of these sessions since beginning. I am very happy to express such a wonderful organizations. Today, I'll take you basics of uh, decision modeling and simulation because this is a unique method, very basic method, but highly popular way to solve a complex problem in almost all domain. And my focus should be just make you all those things how you can develop a bedrocks and conduct a simulation by your own understanding using some examples and some basic concepts so that the students, researchers, and faculty members can take benefit of this to deliver further sessions and pursue research in their respective interest. So let me go with the objective today. In a short time of almost 1 hour, I would try to cover the few things, especially to develop understanding of a model and decision modeling, to describe the methods to generate the random number and computation of simulated data set, because the role of random number generation is very important. Of course, it is not being possible to go for each and every methods specifically because each methods require an intensive 1 or 2 hour sessions. So that's why my intention is to go for the showing the roadmaps how you can build and develop understanding on this particular topic, and you can use it not only in the field of biomedical engineering, biostatistics. Rather, you can apply these generic techniques anywhere into other domains. So the basic things is basic understanding of the simulation concept. So here, the third things, I will try to express some simulation in practice, just a brief about it, not much examples, 1 or 2. So here the first question come in mind for everyone, that what is basically a model is. And here I would like to share with my academic and industry experience that most of the people who are handling the model, training the model, teaching the model fail to understand and express sometimes and commit a blunder in get confused about the model. For example, if I ask someone that what a model is, in a theoretical language, people say a model is a replica of real-time entities to develop a precise and viable solution. Fine, but if you go to this example, consider a very small example. Let force is equal to mass into acceleration is a ninth standard formula. But the question is, how we can say, is it model, is it just a equation or just a formula? So to make it clear, that's a some guideline required whether it is a model or it is not a model, right? Where force is applied on an object, mass is of an object, any that's mass definitely is a inertial mass, and then acceleration produced in the object of mass due to the force it is denoted by variable A. Now, why I can say it is a model? Because there is a necessary condition for a model. The first condition is it must has input output relation variables. So here force is output variable and acceleration is input variable. This is number one condition. Number two condition, it must have functional relation between the output variable and input variable. That means the force is proportional to acceleration here. It means it's a linear relationship between force and acceleration. So the functional relation exists. So this is the second criteria. For a model to be, it is the most important points. So first criteria is input variable, output variable, maybe one or maybe multiple. The second criteria is functional relation exists between input and output. And the third relation is there must be a parameter. The simple model may have a one parameter, complex model might have multiple parameter. For example, in this force is equal to mass into acceleration, the parameter is m. This m is parameter in the sense that it must be inertial. Only a inertial mass would act as a parameter, then the Newtonian theory will work. If the mass is non-inertial, this equation force is equal to mass into acceleration will not be a model, right? Suppose m is not constant inertial mass, like mass defect, then it won't work here. So third is this, and the fourth and last condition is there must be certain constraints. That means it may be axioms, it may be initial conditions, it may be certain mathematical axioms, lemma, etc. Similarly, in the second example, you can say, does this four condition apply or not? So the second example I have taken from a probability model, and we can say that this is a model. Why? Because again, as just I explained, the first criteria is the probability of x is equal to x, that is in fact a y, is an output variable. It will measure the probability, or it will generated by right hand side. So this is output variable. Then x is input variable, where some initial condition and constants are there. X has to be under these limitations. X is equal to 0, 1, 2, 3, like a discrete quantity, and no other than this x, this model will not accept and give the relevant output. So probability x is equal to x is equal to e to power minus mu to power x upon x factorial. In fact, is a Poisson distribution, and it is a model one because it first condition, it has y variable or probability x is equal to x output. Then if you give x is equal to 0, 1, 2, 3, these are the input variable. Then mu is the parameter of this model. And the fourth condition, functional relation exists between these two. And the fourth condition is that this model will work, this Poisson law will work only when number of trials is very large and probability of success is very small. For example, in day-to-day life, you can see happening a special crime at any particular location. There are plane crash, rarely it happen. So any rare event like murder, rape, in the field of development of malign tissue in human bodies, it's not happen oftenly. It happen rarely. Out of 1 lakh people, there are 2 cases of cancer, 5 cases of cancer, like that. So in the real life, wherever you meet a situation which seems like out of the many, there are few cases. So rarest of the rare event, we can apply this model as. So by giving so many other examples, now I hope each one of you are very clear in a differentiating a model from a formula. For example, suppose I say AC is equal, simple interest is equal to PRT by 100. This is not a model. Why? Because in this one, there is no specific laws, no specific conditions, no parameters, and that's why it is a formula. So first of all, the all scientific world and students, especially UG and PG level, must be very clear to define a model and not a model, a formula and a model. This clarity is very important, and that's why my starting focus would be on this concept to clear the concept of model. I hope now most of you never have any confusion in declaring a formula and declaring a model. So here, if I ask a question that if you consider probability x is equal to x, that will give ncx, p to power x, q to power n minus x. Is it a model or not? Can any audience will answer this question? If I given you a probability mass function of a binomial distribution that is given by probability x is equal to x is equal to ncx p raised to power x q raised to power n minus x, x is equal to 0, 1, 2 and like that, can it be a model or not? Again, any would like to say, is it a model or not? Yes, it is a binomial model, right? Because again the four criteria will work here. Why? Because here again there is a parameter. What is that? Number of trial n and probability of success p. That means np is the parameter, a small x is the variable, input variable, and the probability x is at any point x, that is y, is a output variable, and it follows binomial laws. And binomial laws is very particular. It is applicable only to the random event where the outcomes is confined to two only. If the outcomes is dichotomous, that only you can suppose example, a baby born in the hospital, baby boy, baby girl. There are two possibilities, and therefore we can declare it a binomial event. Similarly, tossing a coin head and tail, or a product inspected in a quality inspections may be defective and non-defective. Whether a treatment happened to cancer patient, there might be two probability the patient will come out of the cancer or may not survive. So those events which is having the outcomes limited to yes and no or dichotomous type, we can apply the binomial model there. And of course, with extension of binomial model, we can go to different attributes and different models application depending upon situation and objective at hand. We can apply negative binomial in some cases, similarly multinomial distributions and other distributions. Each distribution is having a specific assumptions, a specific constraints, a specific parameters, a specific variables, and a specific functional relationship. So all those we call it probability distribution model. Almost all parametric probability distribution model is a clear-cut example of a specific model. Even chi-square is a model, though it does not have a real parameter, but the degree of freedom of chi-square make it a pseudo parametric, non-parametric, but parametric distribution. So with that, I hope my one objective is clear, which I want to clear the concept what a model is and how a model is different than a formula and then an equations. Now we'll come to different next level of discussions. Here we observe that, I summarize this, we observe that a model, the necessary conditions are availability of measurables, that is variables, a specific parameters, or maybe one or maybe many, certain laws or axioms or lemma or assumptions or postulates or initial conditions, or etc. And there must exist a functional relation among the variables between exogenous and endogenous or dependent and independent variables. So with that, I'll move to next. What is decision modeling? That is the next thing, or can be called a pre-modeling as a decision modeling, or decision modeling is little different than all other general modeling. Of course, modeling have different categories, different types. So here we say that decision modeling is a scientific approach to make a decision especially suitable to a situation when the outcomes are uncertain. right? This is very important. Decision modeling have role when outcomes are uncertain. In fact, this condition is universal in entire data science nowadays. In the world of uncertainty, if you are asked to make a precise decision, that is a challenge, and therefore the relevance of entire machine learning, artificial intelligence, even in future, we are switching to quantum computing. All these have the meaning if it has ability to address a very precise solution to uncertain problems. That means to reduce the reduce the risk in a decision making process is the requirement of the time, and that is why the world is roaming through data science. So outcomes must be uncertain, then only our topics is relevant and our tools are relevant, whether it is the medical sciences or the defense analyst and other fields of hedging problems in share and stock market and other where. So random in nature and uncertainty is the key word where we make the decision. As such, risk involved in decision is higher. We may refer to decision modeling as a quantitative analysis or a management science. So let's we have some descriptions about decision modeling and general advantage disadvantage. So first of all, we'll say types of decision modeling. In fact, we make it more simple: deterministic and probabilistic. Deterministic models means a model with complete certainty, which is of least importance in contemporary context. Such as a model assume that all the relevant input data values are known with certainty. It is not more important now, and that's why we can see some example: linear programming, assignment problem, transportation problem, and application of these linear programming and all, in fact, day by day is losing their ground. Why? Because it is deterministic in nature. So uncertainties are not difficult to uncertainties are almost impossible to be addressed by this deterministic model. So its important is going to decay day by day, and we are shifting from deterministic to here a stochastic or probabilistic modeling. So the next is probabilistic modeling, or you can say a stochastic modeling. In contrast to deterministic models, probabilistic models assume that some input data values are not known with certain level of certainty. What does it means? It means that the values of some important variables and parameter will not be known, and we have to estimate it. In case the parameters are not, in case rather we can say it's almost in all cases parameters are a unknown quantity, and we use different method to estimate it. For example, in most of the common available tool in a linear model cases, we can use ordinary least square method to estimate the value of the parameter. If we do not follow that, like for a generalized variance cases, or we can go to generalized model, then ordinary least square method is not, OLS method is not working, and we have to go to generalized method. For example, in a linear estimation, linear regression, multiple linear regression, we are generally using OLS. But in logistic model, we can't get a solution of the parameter value using the ordinary least square method, and then we switch to different method, and that is called GLS approach, generalized linear model approach, and maybe the numerical search method approach, or maybe the differential equation approach, or maybe other advanced numerical methods technique to get a solution. But these are the commonly available tools which we talk to. Now, how does it work? So a probability model use probability values. That is the core of simulation. In fact, this is the in fact building blocks of the foundation of simulation in any cases. So first of all, this we have to keep in mind how we start with. We start with a model where we use certain probability values to incorporate the uncertainties. So our first task in simulation modeling is to derive a specific or to measure to start with certain probability values for the event at hand, and then only we can do the subsequent steps. I will show the example. Now we'll go to this remark. Because uncertainty play vital role in probabilistic models, some knowledge of basic probabilities distributions of any kind, we can call it maybe discrete, maybe continuous, and maybe mixed distribution, because all distribution cannot be, all random variable cannot be discrete purely and continuous purely, and therefore in real time we are handling mixed distribution in majority of the projects and cases in almost every field, from medical sciences to pure engineering to economic and business sciences and managerial sciences. So in addition to the concept of a statistical method and tools, this is very important to understand what are the steps involved in decision modeling. This is the next level question, and there are three basic steps which we always apply in developing or decision modeling. One is called formulation stage, another is solution stage, and third is implication or interpretation stage. So first we can see this. Just a minute, slide is to me, it's taking slow. Just a minute, say it's taking time. What happens? Yes, I think it's sorry, it's my system is little slow. So here, formulation stage, we can talk to formulation stage, and this is consist of three elements. One is defining the problem, another is developing a model, and then acquiring input data. This part, three part, defining, developing, and acquiring input is basically our formulation stage. Then, and this is most important steps, because if you define a problem wrongly and not able to have an idea of developing a model properly, you are not having or maybe lost in acquiring the information, right information, which is a challenging task, then the next thing will not work. So the next level is developing a solution and testing the solution. These two is called solution stage. First you develop the solution, and then you validate it or test it using the available sample. You can split the sample, or you can use the part of the sample for validation and part of the sample for testing, part of the sample for experimentation, right? And then you'll go to implementation part, that consists of analyzing the result and doing the sensitivity analysis. And then the last portion is implementing the result and preparing the report. So the next part is what exactly simulation is. So to simulate means to duplicate the features of a real system, and the idea is to initiate a real world situation with a mathematical model to study its property and operating characteristic, to draw conclusion and make action decision based on results of the simulation. So here this is entirely theoretical definition, but we want to show you through a small example how we can simulate the data. So next, here I will come to that after a few minutes. Process of simulation, this is important point. It's a 7-step requirement. First you define problem, then you select the variable very particularly and carefully, because a wrong variable selected and amalgamated into your model will thwart off all your attempt and made your work useless. Then construct a model, and construction a model required a clear-cut understanding of functional relationship between all variable at hand, right? You must know how your dependent variable is related to independent variable. You must know what kind of direct and indirect relationship exists between various independent variable, or the independent variables are entirely exclusive to each other, which is a rare phenomenon which never happened. And assumption of independence of input variables is really a big assumption all through. So far we are doing and searching the best solution and making it a model free from elements of multicolority, but we are not having a single method available so far in any statistical sciences and other sciences which give us or make ensure that multicolority could be reduced to zero. No, not it happened till now. Now, a specific values of variables to be tested, conduct the simulation, and then examine the results, select the best action. Select the best action is the ultimate objective because this is what we are doing simulation, right? But to arrive at this, you have to be careful at each state and a practice and proper understanding required throughout the steps. Any vagueness or any elements inculcated or induced at any of these 7 steps will create a problem in solution or right solution of your problem. So be very cautious even in numerical problems or in ideation, or that means qualitative problems, because simulation even can be applied to qualitative attributes, and that's why the flexibility of simulation is far more advantageous as compared to classical approach. Even Bayesian inferences is now going to adopt additional features of simulation. So Bayesian with simulation is a very powerful tool today than simple simulation approach. So that's a approach I'm talking to where we are going to. In the field of quantum quantity, which is a future, quantum computation, which is coming 10-year future, we are going to hit than simulation using quantum computation, all right? So that's the challenges and opportunity for all scientists and all new mathematical sciences people and machine learning people and other people related artificial intelligence people to adopt easily and make efficient calculation technique in the field of simulation with computing with other modern tools and technology. Now, the next thing is advantage. That's I just simply say few advantage which is very common with simulation. The very first is relatively straightforward and flexible. That's everyone say it is highly flexible, not so like a classical model. So that is the first advantage. The second advantage is it can be used to analyze large and complex real-world situations that cannot be solved by using conventional decision model. For example, it may not be possible to build and solve a pure mathematical model of a city government system that incorporates important economic, social, and environmental and political factors, but it is quite possible to analyze large and complex real-world situations that cannot be solved using conventional decision in such a system, but it could be possible to simulate the hospital system and biomedical engineering system, the urban model system, educational system, national and state economic system, world food system, at all macro level system, we can incorporate the simulation. So the fourth advantage we can say simulation allows what if type of analysis, what if type of questions and subsequent to answer. A manager can handle several policy decisions using simulation with a short span of time, and that is a very important tool in managerial sciences in every domains. The next advantage is simulation do not interfere with real world system. With simulation, experimentation are done with the model, not an system itself, and therefore it is highly useful. And now we'll talk about some of the like that few more advantages. I can skipping it here. Maybe the fifth advantage you can say simulation allows us to study the interactive effect of individual component or variable to determine which ones are important. Similarly, the next advantage are time compression is possible with simulation. For example, the effect of ordering, advertising, and many other policies over many months or year can be obtained by a computer simulation model in a very short span of time. So that is fast way to achieve the survey and fast way to achieve and accomplish the task at hand. And the next advantage, that is the seventh number advantage, is simulation allows for the inclusion of real world complications that most decision model cannot do so far. But it suffer from some disadvantage also. And what are those? There are so many small level disadvantage. The first disadvantage is simulation cannot be done by an little or untrained people. So it requires highly specialized people to do simulation that have a core as well as the related functional expertise. So here, good simulation model can be very expensive. It often a long, complicated process to develop a model. For example, a corporate planning model can take months or even a year to develop. Similarly, the next disadvantage is simulation does not generate optimal solution to a problem, right? It is not a optimization tool. So it cannot generate optimal solution to a problem as do other decision modeling techniques do. For example, LPP, transportation, assignment, and many other optimization tool will do the optimal solution. It's not the job of simulation. So simulation may achieve towards optimality, but itself is not a optimization tool. And the third disadvantage is simulation may be a trial and error approach that can produce different subjective type of solutions. There may be a lack of objectivity in simulation result. You can achieve different results with different logic by different simulation approach, and that subjectivity is both merit and demerit of a simulation. So that a cautious approach required to be there. Generally, for a project and scientific work which need to be done objectively, be in that context, take simulation as a disadvantage. And the fourth disadvantage is simulation model does not produce any answers by itself. So manager must generate all the condition and constraint for solution that is required, that want to examine. So there is nothing in itself in simulation. Everything is lies in a team of people and team of the leaders and a special person, technical persons, and the domain expert person who apply the simulation on a particular event and particular situations. So here, now I like to go to some discussion on the basic and very first way that's called Monte Carlo simulation technique, MCS technique. But I made it so simple without going to any complexities. I try to give some example. So what do you mean by Monte Carlo simulation approach? Here, the solution is when a problem, I deliberately made this in a way that the question answer should come in your mind and you get the answer in that way. So solution is when a problem contains elements that exhibit chance or probability. First requirement, the existence or exhibition of chance. If a problem do not exhibit any chances or basic probability associated with it, we cannot apply MCS technique there. So the first requirement is the elements must exhibit the probabilistic characteristic or measurables in chance must be there. Then the next is, these are the steps, we can call it basically the MCS steps. The first, establish a probability distribution for each variable, and you should be very clear into that which events follow which. For example, if you are handling a criminology or doing a crime research, you must know your criminal events or the events which you are handling follow which distribution or which are the close distribution handling and explaining that particular event. The second step is using random number. That is very important. So the role of random number in simulation is vital, and I'll discuss it, different methods of random number generation. So using random number generation, simulate the values from the probability distribution for each variable in step 1. These steps would be clear in my small example, which I am going to discuss in few minutes. Repeat the process for a series of repetitions, that's called runs or trials. And then next question. So these 3 steps you have to do. 1, establish a probability distribution. Second, generate a random number and generate the simulated value based on the random number. And third, repeat the process for a series till you achieve the objective. Now, why we want to simulate a variable? The answer for this particular question is because there are many elements of uncertainties in a variable of measurement. Many variables in real world system are probabilistic in nature, so we wish to simulate them. Otherwise, it is not being possible to determine and estimate those unknown parameters which based on these variables. Then now here some just a common example I would like to say, though there are list is pretty long, but generally these are the areas where usually people are using simulation commonly in everywhere in industry, like in a product demand, lead time or order place demand, time between machine breakdowns, right? In a pharmaceutical company during COVID time, you have seen a big supply chain management and lead time roles in availability of different types of vaccine in stocks and implementation. That's the supply chain and logistic problems are there, and that makes the success of our COVID story in India, because our government and particular industry people and the entire people of the country are doing very well job in maintaining all those distribution system and forwarding and supporting to the government policies implementation. So where simulation can be a very fruitful job to do. Time between arrival for a service facility window and service time problem, time to complete a project activities, such a problem could be simulation very much or easily adopted. Number of employees absent from a work on given day, that problem can be sorted using simulation. And stock market performance, I have listed just few. There are wide lists, more than related to almost every domain of human activities nowadays is where simulation is under use. So just for highlighting the concept, I mentioned few one. Now we'll move to illustration. One small illustration I would like to give here to illustrate how we establish a probability distribution for a variable. So the steps are, first of all, let's consider just I take a small problem to demonstrate, and this problem could be from any field. So I have considered a small problem for demand of a specific tire at any particular auto shop, or you can say a retail shop, in last 5 years, 60 months. Or this data is available. The data are shown in first two column. This is like that. This you can see here. This is the demand per month: 300 tires, 320 tires, 340 tires, 360 tires, 380 tires, 400 tires. These are actual data that a particular auto shops having the demand in a particular month. So there are 3 different months in a last 60 months, because this data is for 5 years. So there are 3 months in which 300 tires has been demanded, 6 months in which 320 tires has been in demand, and like that 340 tires being demanded in 12 months, and 360 tires having the demand how many months? 18 months, and 380 tires is being sold, or you can say demand, during 15 months, and there is only 6 month time where more 400 tires are being demanded and under sold market condition. So total is 60 month, fine, and this is actual demand. Now first of all, I am going to make without talking any software and all approach of simulation and all, that elementary way to do the simulation is understanding this question. So what is the first step? As I explained, you generate the probability. How do you generate the probability? Because these are the frequency, and this is total frequency. Capital N is equal to sigma Fi. So if you divide each frequency by capital N, it will give you relative frequency, and that relative frequency is basically a empirical approach of getting probability. So if you divide 3 by 60, you will get 0.05. So probability for during last 5 years or 60 months, probability of 300 tires being demanded is 0.05. And similarly, we have calculated for 320 demands, the corresponding probability we have calculated as 6 upon 60, and this is our first requirement. So for any simulation to be done in any field, the first requirement is generating this basic probability. For maybe here it is demand, maybe there is a different X, right? So the events could be different, right? Maybe per month, per day, or maybe any specific time, but basic probability you have to calculate. Then only you can apply the MCS method, right? So this is now the next step is, you can see this is the first step. So this is our problem, and this I have generated probability. These are given to you, all right? And then the next step is how to do simulation here. You can check it here. The first of all, you do what? You calculate before going to simulate it. First you calculate. If you see here, this is X and this is probability Pxi. So we know how to calculate expected X. So calculating the expected X is a formula summation Xi into Pxi. Similarly, if you want to calculate expected X square, you do summation Xi square. Here you do the square. Then expected value of X square could be calculated as sigma Xi square into Pxi. This is nothing but definition of expected value for discrete cases. So for this problem of tariff demand problem, I got the expected monthly demand. How do we do that? 300 multiplied by the corresponding probability 0.05 plus 320 multiplied by corresponding probability 0.10 and so on. We calculated the expected value. It comes 358 dash. Fine. That is the one calculation we have done. Now at this stage, I suggest you people that you also calculate expected X square here. So how do you do that? You just do, this is Xi, so you make Xi square and multiply this Xi square value. So make a column here Xi square, 300 square, 320 square, 340 square, 360 square, 380 square, 400 square, and then multiply it with this probability and then add this. Then you can calculate expected X square values using same formula, right? And then you can calculate the variance. How do you calculate the variance? The formula of variance is variance of X is equal to expected X square minus expected X whole square. Once you calculate the variance, right, using the formula which I said you right now, expected X square minus expected X the whole square. That is the basic elementary statistics. You can also calculate the standard deviation, right? Because standard deviation is a square root of the variance. So before moving to simulation, this is called analytical calculation of calculating the mean, the variance and the standard deviation for a given demand data. So that is the first step. Now what you do next is a step 3, make use of random number to simulate the demand. How do we do that and how do we convert? So next step is required how to generate random number, because role of random number generation is very, very important in simulation. So doing simulation further, you can see it here. Demand is given to us, probability we have calculated. Then next step is cumulative probability. So what you do, you create cumulative probability like that, keep on adding your initial probability. For example, 0.05 plus 0.10, it becomes 0.15. Then plus 0.20, it becomes 0.35, plus 0.30, it becomes 0.65, plus 0.25, it becomes 0.90, and finally, if you add 0.90 with 0.10, it becomes 1. So total probability is 1, and this column you can create it, right? Just for the sake of basic elementary way how to generate the simulation. This is the steps further, and then you generate this column, next column, that is called random number interval, generating random number interval. So it will be based on this cumulative probability column. So since it is 0 to 0.05, so we can say you can generate the interval 0 to 4. Here it is 5, therefore you can take one less than 5. So 0 to 4 is the random number interval for corresponding to cumulative value 0.05. Similarly, next interval is 5 to 14, because here 15. So from 5 to 15, that, and then subsequently you can develop for all. It is 15 to 34, because 35 is the cumulative, so it is less than 1. 34, and then 65 cumulative, so it is 64. 35 to 64, and 65 to 89, and 90 to 99. This is our next step before calculating the simulated value. So now what we do? Now the next step is we require certain random number, right? And you can know that the random number generation can be done in Excel. There are a specialized software, even in Excel, in MS Solver. For example, suppose you use rand command in Excel, it will generate random number, right? Similarly, suppose rand between 0 to 80, it will create random number between 0 to 80. If you use others, there are random number generation using univariate or uniform distribution or Poisson distribution, binomial distribution, all you can do it. Even in R, you can do, for example, if you want to generate random number using Poisson distribution, you can use rpoise. The command rpoise will generate random number from Poisson distribution with known lambda. If you want to generate random number using normal distribution, you know rnorm. If you use rnorm and then give the parameter of a normal distribution is what? The mu and sigma, right? So you can generate random number from any distribution, for exponential also, Poisson also, for binomial distribution, R binom. So you can generate random number in every software. That I will talk to you some specialized software which is exclusively specialized, and even I give a comparative examples in subsequent slides. So here random number generation is required. So, now there is a clear understanding and important point. If you generate 3 and 3, this is the 6 real demand, you want to generate only 6 simulated demand, then you have to use 6 random number only. But as a scientist, I suggest you, if you generate more and more random number, your random number size is larger, then simulated value will be as many as possible. And to get the precise answer of an uncertain condition, high level of, and that is why you can see a event is simulated 5,000 times, 10,000 times. For example, suppose you use a scan statistics to generate a hotspot, right? In many of my research work, I have used it, and other students who is being under my guidance, they have done a lot of work using scan statistics in different fields. They have generated the log likelihood ratio values and all. They have used simulation using that software 5,000 times, 10,000 times. Then the p value generated will be more reliable and more specific and as close to as possibly 0. And that's why their decision making is good and accuracy would be very high. So suppose for a simple example, we would like to generate only 6 simulated demand. So consider the 6 random number in the next step. Any random number you can use. For example, here I have written step 4. Now to simulate demand using the number interval, we need to generate random number between 0 to 9. Why between 0 to 9? Because here in this table you have seen, this is 90 to 99. So from 0 to 99, we can generate as many as possible random number, 100 random number. You can generate any random numbers, right? Maybe, and corresponding to each random number, you can generate simulated demand. So that's why you want to explain it here in a step 4. Now to simulate demand using the number intervals, we need to generate random number between 0 to 99. We may use random number table, or there are various other ways as I explained you. You can use MS Excel and you can generate random number. You can use the software R, Crystal Ball, at the risk, etc. Simulink in MATLAB is specialized for doing simulation. So that's our embedded software in the MATLAB. Similarly, MS Solver is embedded into MS Excel. You can use MS Solver to generate random number. That is quite easy to do it. And Crystal Ball is a specialized random number generator and the simulation software. Like that, there are many. So suppose we have generated random number. Suppose I say 25, 39, 65. What I say? One is 25, another is 39, 65, 76, 12, and 5. How many? Just 6 random number I have taken. I can take even 100 random number between 0 and 99 and generate 100 simulated demand. But just for illustration, I am just taking 6 random number. But it should be not decided by you. It should be generated, because if you decide the random number by own, it will not work. It should be properly done by using random number table or any of the methods, right? Then only it will work. So you take this number. Now using this random number and random number interval which is shown in the previous table generated just above, we can easily generate the simulated monthly demand of the tire as follows. You can see it now here. Suppose this is your actual demand: 300, 320, 340, 360 tire, 380 tire, 400, and these are our 6 random numbers, right? Generated through the random number table or any method. So suppose we have random number 25, we will check it. This random number lie in this interval. So you can see the interval here. You can see here 25 lie between this one 15 and 34. So what is the corresponding demand here? 340. So for random number 25, the simulated demand is 340. You can check it here. Similarly for 39, that is another random number. Go to the previous table. 39, it lies where? Between 35 and 64. What is the corresponding actual demand? 360. It means for the random number 39, the simulated demand is 360. And for random number 65, similarly, simulated demand come as 380. For random number 76, it is like 76. If you go to here, where do 76 lie? Between 65 and 89. So simulated demand is 380. So that's why for 76 here, simulated demand is 360. Sorry, 380. Like that, for 12, the simulated demand is 320, and for 5, simulated demand is 320. Now, this is the way I have shown you the most primary way to simulate the random number, simulate the demand, generate using random number, right? In a most of the software, they will give the result and you are using it, but you don't know how it happening. So since basic of the understanding of manual calculations and other thing is not known to you, you are not in a position to debug it or properly use it. And that is my focus of the session today, that how you can generate your own simulation. You can apply this technique to any of the problems at hand, where you must know the actual few data and few initial frequency or probability. You can generate multiple simulated value, and then you can, once you generate this simulated demand, now you can do what? You can do, suppose there are only 6 simulated demand, you can generate 100 simulated demand and find the mean, variance, standard deviation, coefficient of variation, skewness, kurtosis, all statistical, basic, descriptive and exploratory, absolute and relative tool you can find out for simulated data. And when you compare this for the past, the actual data, you will find a great improvement in your inferential ability and decision making. So I suggest you, most of the time where data set is a problem, you generate simulated data. As many student and researcher working, sir, what I can do, I have just a 50 data set. Many students and researcher, they are saying, sir, I'm not able to get it even in 2 months. This is not possible, sir, to get more than 50 data on this particular event. I say, well, let's you got it 50, but simulate it 1000. Do the simulation and increase your sample size and work on simulated data. Take a decision. 100% you are going to get benefit, and 100% you are going to address all those uncertain problems which you are not able to estimate, build just merely with 50 data. So this is the biggest advantage. I hope the audience understand how to generate simulated demand. But I suggest here, simulate as many as possible, because larger number of simulation is really going to take you towards consistency, unbiasedness, sufficiency, and consistency, right? So as many as possible, but it does not mean there is no upper cap. Suppose you generated the 10,000 simulation data, now you are generating 15,000 simulated data, are getting no improvement, better you stop at that point, right? So there are some points where you do not get any improvement in your improvement means in a sense of a statistical gain. statistical significant. If you are not gaining with simulated data, stop that level. Don't do simulation more than that, which is the threshold level of simulation, right? So now I move to some few minutes time on some techniques. I think many of the students and people are aware, many of them not, though it is not being possible to cover each of the methods in a one session. But I would like to highlight here that there are different random number generation ways: random number variable generation method, random number generation method. These two things are very important to know about the researcher and for the students and faculty members. So a random number is a number that has been selected through a totally random process. There are several ways to pick random numbers: using a computer, using a random number table, and using some statistical methods. And these are the basic methods which I always say, let's apply it. For example, statistical methods, congruential methods, in inverse transformation method, acceptance rejection method, nowadays modified acceptance rejection method, this one, because acceptance rejection method is having a particular disadvantage, that it cannot be applied on distribution having closed interval, right? So for example, you can't apply inverse transformation method on normal distribution. So convolution method can be applied on normal distribution, and similarly modified acceptance rejection method can be applied on normal distribution and other methods. One method is also called normal distribution method to do the simulation and to do the random number generation process generator. We call it, all those methods will give you process generator. Using that process generator, you can find as many as random number as possible, though it is no need to do it manually nowadays, because most of the software have these features and command to do this work nowadays automatically. But my purpose is to make you clear these things inside a story rather than going for just a software application. And that is why the major chaos happening. A electrical engineer working without understanding, just based on the SAS output and Python output, they fail to understand what's going on inside. Or economics person working as a data scientist without understanding the real statistics, what is going behind it, what are the mathematics inside it, and that's why the problem is very serious. So since there is a job here, there is a revolution today in data science. Everyone want to jump into this field, and therefore I caution the people that without having a proper mathematical understanding, and especially the advanced statistical understanding, please don't jump into it. Otherwise, the software, and based on the software, just doing something, getting something, is really going to make a very difficult situation, which is happening nowadays. Now I'm going to move to next steps. That's will few. I'll take, I think, 5-10 minutes more. I can maximum I can take. So here the next is the discussion on this one. There is, I would like, because I can do the proper talk on each of the methods, but that is not being feasible here to discuss with you. That you can take this. I'll send my entire slide to Professor Dilip Kumar Chaube, and from he can share you with each one of you if you want to work on it and develop. And there are a lot of digital platform and ebook and all those things. You can use the artificial intelligence. There are a lot of things which is coming today, and you can take a note on it, and you can work on each methods and become expert of it. So here I would like to have some comparative discussion. MS Excel built-in versus Crystal Ball. Both are the software. In MS Excel built-in, this is inbuilt command, and Crystal Ball is basically a specialized embedded system that will generate. So when you generate, your objective to simulate from what continuous informed distribution between A and B. How we can use MS Excel built-in? You can generate here between A and B. What you need to do, you can see it here, that in a Crystal Ball you can use cb.inform A comma B. It will generate continuous informed distribution random number between any given number A and B. Suppose A is 2 and B is 10. If you use this command cb.inform A comma B, it will generate. But if you use MS Excel simple, then what you need to do? Rand between A and B, right? So rand between A and B will give you any, but it's not make you ensure about informed distribution, but make you go to MS Solver. They have given you choices of informed distribution, choices of certain other distribution, and they ask you just fill up this variable. You require one variable, how many random number you require. If you give those input, they will generate you properly and give you. You can see it here. If you want on Excel today evening, you can go there and go to data and go to MS Solver part, and there you can see these features are there. Right now, discrete informed distribution between A and B in a crystal ball, it is cb dot discrete inform. This is the command. A comma B, these are the argument they require, and when you do enter, it will generate discrete informed distribution between number A and B, where A may be 50, B may be 100, A may be 10, B may be any other numbers, like that. From normal distribution with known value of parameters mu and sigma, if you want to generate random number using crystal ball, you can use this command cb dot normal mu comma sigma. And similarly, from exponential distribution, you can use the command equal to cb dot exponential mu, where mu is the parameter of exponential model, or maybe lambda you can put. Lambda may be also in place of mu, you can use lambda. And for Poisson distribution, again the Poisson distribution having a parameter mu, so the mean rate is mu, and therefore you can use cv dot Poisson mu. It will generate random number using Poisson distribution. And then using binomial with parameter n and p, you can use cv dot binomial p comma n. And then triangular distribution with minimum value A, most likely value B, and maximum value C. How do you use? You can use the command cb dot triangular, where 3 argument has to give for A, B, and C. What A denote? A denote minimum value. What B denotes? Most likely value. And maximum value is denoted by C. So when you give this value A, B, and C in a cb dot triangular, it will generate random number, and then you can generate as many as possible. So these are just an illustration how you can generate random number using crystal ball formula. Now to simulate from MS Excel built-in function, because I have just here displayed how you can generate random number using this crystal ball. Now you can generate random number, which is known to you. Most of you perhaps know it, that if you want to generate a continuous informed distribution between A and B using MS Excel built-in function. Built-in function means it's a part and parcel of Excel. There is a third-party software that is embedded into MS Excel, that is not built-in but third-party. For example, MS Solver is a third-party system embedded into MS Excel, right? At the risk is also embedded into as a third-party into MS Excel. So students and researchers, I always talk to them, be very strong into MS Excel. Don't underestimate it. There are this is much more powerful calculating devices compared to any other, rather than just going for Python and R and other things. That is fine, but go for a strong conceptualization and practice in MS Excel. It has a lot of things, especially computational software. It is most powerful. Rest all software will import and export this MS Excel spreadsheet, and they do that. So discrete informed, suppose your objective is to do to simulate from discrete informed distribution between A and B. How do you use? As I was explaining you, you can use rand between A comma B, or you can use int command. Int means integer. It will not give you the fraction value, only integer value. A plus B minus A plus 1 a star rand. It will generate the same thing, rand between A and B. You can practice it today on MS Excel, and you can see how many, and you will find it interesting to generate the value. Say in normal distribution, if you want to simulate from normal distribution with known value mu and sigma, you can use norm inb, then rand command first argument, then mu as the second argument, and sigma value as third argument. So these argument value you have to give, like mu is equal to 2 and sigma is equal to 1. That kind you can give it, and then norm inb you can use. It will generate normal distribution with mu and sigma. Similarly, exponential distribution, suppose you want from exponential distribution with a given mean rate mu, then it is 1 upon mu star ln into rand. Argument is rand here. Rand with empty shell, you can give this value, but mu value you have to give. Mu may be 2, mu may be 3, or mu will be whatever the actual values of exponential distribution parameter, you can give it here. Now random number, simple random number without any distribution. If you want generate that also, you can generate in Excel. Just use rand in any cell of the Excel, empty shell. You can use rand and then enter. After this emptying this, you will find it that random number generated. You can drag it as many as number you can want to, suppose 100 times, you can drag it 100. It will generate 100 different random number. So discrete general distribution with two outcomes A and B, probability of A is P. In that case, you can use in Excel, if rand is less than P, comma, A, comma, B, it will generate random number and do the simulated values. Now discrete general distribution with greater than two outcomes, that means is a case of multinomial distribution. When there are two outcomes is a case of binomial distribution. So in a case of multinomial distribution, any example of multinomial distribution? The multinomial distribution example is the chi-square cannot be worked if the distribution is not multinomial. All right. So multinomial distribution give at least two output, but more than two output in most of the cases. So discrete general distribution with greater than two outcome, range is equal to 1 is equal to cell range containing lower limit of the random number. Range 2 is given as equal to cell range containing the variable values. Now you write it, use lookup rand. So lookup is the command for that, and argument is rand. Then range 1, that is the range 1 explanation here I have given, and range 2, the range 2 explanation is cell range containing the variable value. If you use this here to here, it will generate the random number, and you can use that random number to simulate from this distribution. So this is the way, few examples I have given. My attempt is to show you the roadmap, how you can work with and how interesting this is. You can generate random number for purpose of simulation depending objective on your hand. So with that, I would like to summarize my talk, what I have discussed just now, recall it, and that is the first point. I discussed about basic of model and the basic definition and certain constraints criteria, when you call it a model or not call it a model, how you can differentiate between a model and formula, does a particular formula is a model or not, right? So these things is very important. Identification of model before using it, and you want to develop a model, then you must follow those 4 criteria which I have explained. What are those 4 criteria? The first criteria, it must have a functional relation between y and x. Second criteria, the input output variable has to be there. The third criteria, parameter, certain parameter 1 or 2 or even more parameter could be there. And then certain mathematical assumptions or linear condition or a state condition or mathematical constraints or some initial conditions or some lemmas or theorem or laws, very specific particularly to that particular things, that must be there. If you apply Newton formula to Einstein theory, it will not work, because in Einstein theory the mass defect concept is there and m is not a parameter. That means m is not an inertial mass. So F is equal to mass into acceleration only work in a Newtonian inertial motion, not for Einsteinian theory, right? Similarly, many examples you can view and perceive and think of. So process of decision modeling, I have given different process. Then I have discussion over deterministic and stochastic modeling, how you can get benefit of a stochastic modeling. Today is the world where deterministic modeling is almost faded. Nobody is going to work and take a decision based on deterministic modeling. It is just a mathematical practice now. So stochastic modeling is the order of the time, and that's why people are moving to a stochastic modeling. You can call it random modeling, you can call it a statistical modeling, you can call it probabilistic modeling. But deterministic modeling means pure mathematical modeling, which is not being into fashion now. Simulation modeling, that means you can use simulation using any of the softwares, and you can do simulation using a spreadsheet, you can do simulation using other software. Steps involved into simulation is discussed with you. Monte Carlo simulation, MCS, basic definitions and approach I have demonstrated. using example. So illustration of MCS I have given, and methods of generating the random number. I have just discussed to you different methods, like using giving you a table example how you can generate random number using the MS Excel built-in, or you can generate random number using crystal ball. I also give that you should try to generate random number and work the simulation using at the risk, or you can go to Simulink in MATLAB, etc. And then use of even SAS. So if you know SAS, then the complete package are there inside SAS. You can do the programming in Python also. It is available in R. You can do so almost Minitab you can do, even Stata you can do, right? So a StatCraft is also doing simulation. So all software almost is very much focused on that. So use of MS Excel built-in and crystal ball add-in, random number generation. These are the highlights of my talks for this almost 1 hour talk. I hope I have crossed the limit of time. If then, I'm sorry very much. But if no, then it's fine. Now I would like to stop at this point, and I would like to share with you if anyone is having any end note or any queries and all, then please most welcome. Thank you so much. Should I stop at this point? Can have any questions and any discussion right now?
Any question, please ask him, sir. Is there any question you may ask him, sir?
Yes, yes, you can discuss frankly and you can discuss and talk. Should I stop sharing the slide?
Yes, sir. Yes, sir. No question?
Yes, audience. I think I might be very fast, Dilip sir. Is it need to
No, no,
be?
no. The lecture was so much good, sir, and yeah, it was okay. So, okay. Thank you, sir, for taking the time to share your knowledge with us. Your talk on decision modeling and simulation was really informative. You explained models to us, including what they are, how to teach them using a simple example, and the relationship between parameters and variables. You talk about decision modeling, its benefits and drawbacks, and how it applies to everyday life. A brief explanation of the many types of models and how they function. What procedures comprise a decision model in the real world? You informed us of the simulation and how it works. The addition of case studies in your explanation definitely made it easy to understand them. Again, sir, I want to express my gratitude for sharing your valuable time with us. Thank you so much, sir.
Thank you so much, sir, for all these wonderful organization, and thanks a lot to the audience. Many of my students are attending the sessions. Anga Shabu, I have seen Sonia Kendall, I have seen Sumita from different areas. Some are from Kerala, some are from Vellore, some are from Patna, some are from Noida. So really, I'm very pleased to find all these people here, and I express a sincere thanks to the organizers, especially Professor Dilip Kumar Chaube. Sir, do it and continue with work. I would be the part of this next session, and I would try to attend this. Thank you so much, sir.
Okay, sir. Thank you so much, sir. Your next session will be start. Just wait for a few minutes. I am discussing with. Contacting with the resource person because I gave him time 4:40, but right now 4:20 is there. So just wait and okay. Next session will start soon. No need to leave it. Okay. Please take break. So I think Sandeep Raj sir has joined. Sir, have you joined?
Yes, sir.
Yeah, okay, sir. Hearty welcome, sir. And thank you for providing your precious time for this STC. So I am going to introduce you about our resource person. Dr. Sandeep Raj is a member of IT Pali. He received the BTech degree in Electrical and Electronics Engineering from Allahabad Agriculture Institute, Deemed University, Allahabad, India in 2009. The PhD degree from the Department of Electrical Engineering, IIT Patna, Bhita, India in 2018. He received DSc Inspired Fellowship awarded by Department of Science and Technology, Government of India for pursuing PhD. He is currently serving as an assistant professor with the Department of Electronics and Communication Engineering, IIT Bhagalpur since 2018. Prior to IIT Bhagalpur, he was a visiting faculty with the NIT Patna, India in 2012. His current research interests include biomedical signal processing, embedded system, machine learning, and IoT. So, okay, sir. Thank you, sir. So, hand it over to you, sir. Please.
Thank you for the introduction, sir. So, today's topic of the discussion is, first of all, I would like to thank the coordinator, Dr. Dilip Kumar Chaube, sir, for inviting me for this lecture. The topic of today's discussion is pulmonary disease detection using artificial intelligence. So we will just talk on the one application of the artificial intelligence in the domain of biomedical engineering. So first of all, pulmonary disease means what? Pulmonary disease are related to the diseases that are related to the lungs or chest of a human body. So we are basically interested in automatically detecting the diseases using the applications of AI. So we will be discussing what are the steps one by one, what is the literature that has been done and how it is done. So first of all, what is the significance of this topic? So as per the report of World Health Organization, the mortalities due to the lungs diseases in India has increased up to 11% of the total number of deaths. With 18% of the global population, India has disproportionality high 32% of the daily disability adjusted life years from chronic respiratory diseases. In every 0.1 million of Indian population, an estimate of 142 cases are declared as dead having any type of lungs disease. The chronic respiratory diseases include the tuberculosis, asthma, interstitial lungs disease, pneumonia, COPD, and these diseases have emerged as a major health concern in the nation. As per the recent report of Global Burden of Disease, a substantial number of acute and chronic respiratory diseases are prevalent in India. Among the chronic respiratory diseases, asthma and COPD are the major regions of morbidity and mortality across the several states in India. As per the another report of ICMR, Indian Council of Medical Research, pulmonary fibrosis is found in 15% and COPD in 5% of males in India suffering from the respiratory diseases. In the past quarter, COPD is now ranked as the second leading individual cause of disease burden in India. In 2016, the prevalence of COPD and asthma in India was 4.2 and 2.9 respectively. So these diseases or signs of diseases that are found in the human chest are typically noticed by a doctor using the chest X-ray. And if Considering the large population of India, it is a tedious job for a doctor alone to have to check such large number of X-rays. Every year, a total number of 35 million chest X-rays are done in USA, and the radiologist has to study approximately 100 chest X-rays during the day, which is a tedious job. So from this, a motivation comes that there should be an automated system. Either it can be in a form of software or a CAD system, computer aided diagnosis system, or some kind of device we can also propose so that one can easily have a prima facie information about the condition of chest. So these chest diseases are caused in both the males and females. So in the middle of the image, we can see that these chest diseases are one of the reason of the chest diseases is ambient air pollution, household air pollution, smoking in males, occupational risks, ambient ozone pollution, and the second-hand smoke. So this is the burden of the diseases in India. These are the main reasons. So the tools employed for getting the information about the chest are chest X-rays, computed tomography, which is the CT scan, and MRIs. The reason behind I am only talking about X-ray is considering the cost. The cost of CT and MRI is approximately 10 times of that of, or more than that of chest X-rays. So let us first of all see what these tools can give us the information about, and then we will go on the chest X-rays. It is obvious that MRIs and CT scans can view the internal body structures, and since they involve more cost, they give more information also. A CT scan is faster and provide pictures of tissues, organs, and skeletal structure, while an MRI is a highly adept at capturing the images that help doctors to determine if there are abnormal tissues within the body. MRI are more detailed in their images, means they provide more information. Using the radio waves and magnets, MRIs are used to view the objects inside your body using a constant magnetic field and radio frequency bounce off to the fat and water molecules in your body. So radio waves are transmitted to a receiver in the machine, which is translated into an image of the body that is used to diagnose the issues. Chest radiographs obviously provide less information than the MRIs as well as the CT scans, but the reason behind choosing is, as I have said, regarding the cost. So it is not possible to have a detailed information or the internal structure regarding the tissues or organs in case of chest radiographs. So the chest radiographs is the most common low-cost screening and diagnostic tool commonly used to examine the condition of lungs of a patient. Chest X-rays produce the images of heart, lungs, blood vessels, airways, the bones of your chest, and spine. Again, it is used to detect the abnormality in the heart, lungs, aorta, and bones of the chest. So what are the informations which we can get using the chest X-rays? The condition of our lungs, heart-related lung problems, the size and outline of heart, blood vessels, calcium deposits. We can also process the chest X-rays for
Excuse me,
finding. Yes.
So the slides are not changing.
Okay. Now it is visible?
Yes, sir.
Okay. So we can get the information of our lungs, the heart-related information, the size and outline of our heart, blood vessels, calcium deposits, fractures. Fracture determination is also a different problem that we can use, where we can use the AI for detecting the different kind of fractures in the human body using using X-rays. And what are the post-operative changes, as we have seen in the case of corona, that after getting the doses of injections, there are a lot of variations inside the chest. So basically in this study, we will focus on the chest X-rays capable of detecting different kind of diseases. These include the cardiomegaly, fibrosis, infiltration, effusion, ectacalysis, nodule, mass, pneumothorax, consolidation, tuberculosis, pleural thickening, edema, pneumonia. Many of the research papers have considered the chest X-rays for COVID-19 detection, and hernia and many other kind of signs that are present that can be identified using chest X-rays. We can study the chest X-rays for detecting those. So the basic aim of our study is to automate this manual procedure, and that we are going to do after the application of artificial intelligence into this domain. So these are the different signs that are present in the chest. Like we can see some kind of patches in the case of mass, a dot-like structure which is called as the nodule. Pneumonia is also a kind of patch. Haziness is there in the image. So different signs are there for different kind of abnormalities inside the chest. And these doctor finds in the chest images and then gets diagnosed. So the motivation is the X-ray machines are having huge in size. They are restricted to ICUs and high-tech hospitals, and it is analyzed by a radiologist in an offline mode. There is no such device that is available in the market which is for common people and that can automatically diagnose the chest X-rays. So there may be some kind of solution in a real time, and that can be capable of performing automatic diagnosis. And for this, we require the image processing and computer vision techniques. We can also implement those techniques for the development of a device, which we will see a bit later. So these are the objectives. As we can see that in this image, the different steps has been mentioned. This is the input chest X-rays, which we gather from the machines, X-ray machines. And these are processed, either it can be a computer or it can be a device where we can put the image for further processing. So the key steps in processing the chest X-rays are pre-processing, where we are basically aiming to reduce the different kind of noises, or if the image is blurred in nature, so different kind of noises are being removed. We enhance the images. So image filtering and enhancement is done in this pre-processing stage. In the segmentation stage, we are basically aiming at extracting the lungs part in an image. So we can see that this is a normal picture of a patient, chest X-ray image of a patient. So we can see that a lot of information is provided which is not required in our study. We are basically aiming at extracting the image of the chest and what are the signs of the different abnormalities that are in the chest, that we have to find out. So the rest other, all the parts are irrelevant to us. So this is called the region of interest. So in the segmentation stage, we are basically aiming at extracting the lungs out of the complete chest X-ray. Then after, in the third stage, we are basically extracting the features of those signs. If we are having pneumonia, it has a different sign. If we are having, in some cases, if we are having COVID-19 or pneumonia or cardiomyopathy, so they reflect different kind of signs. So we are basically extracting the features of the different signs or the different diseases, we can say, using some methods. There are a lot of methods which we will see a bit later. And finally, the extracted feature form the different type of signs or the diseases are classified using the machine learning or the deep learning techniques. So this is the complete 4 or 5 steps, because in the pre-processing we have considered the image filtering and enhancement. So these 4 to 5 steps are basically responsible for the automatic classification of the chest X-rays. So that can be done either in a computer or the computer-aided diagnostic system, or we can also propose a device where these methods can be implemented, and finally we can diagnose the chest X-rays. So there are a lot of scopes. So first of all, we should discuss about from where we should get the data, because the data is the most important factor in AI. So in this study, we have considered the NIH chest X-ray dataset. It is also available on Kaggle, and it contains around approximately 1.25 lakhs of chest X-rays. So that is a huge number. It consumes a lot of memory. So a proper graphic servers is required to train all the chest X-rays. And it contains these 14 to 15 different kinds of abnormalities inside the chest, which we have seen earlier, like cardiomyopathy, fibrosis, infiltration, effusion, and all of these abnormalities. And we can also design a hardware. So basically there can be two solutions that can be given to an end user, either in kind of form of software. The software can be delivered to the end user using 3 types. Either it can be in a form of exe file, either you can develop it on the web-based solution or deploy on a web-based solution, or you can give a Android application that can be installed on mobiles, where you can receive the chest X-ray either in your WhatsApp, or you have a existing X-ray of some patient on your mobile, and you can classify or diagnose the chest X-ray on the same platform. So in the software technique, you can deploy using these 3 types and form a solution, end-to-end solution, and give to the user. Or either you can do one thing also, that you can develop using some kind of commercially available hardware microcontroller platforms. You can develop all these methods using any language, like you can go through C++ also, you can go through Python also. And you can take the chest X-rays using the Wi-Fi on that device, or you can take the chest X-rays through the USB port in the pen drive. And after accessing the data on the platform, whether it is a kind of a software or a hardware solution, because our data is collected from some outer machine, so we have to bring the data to the platform. Either it can be a computer or it can be a hardware device. So you can take the data from Wi-Fi also, Bluetooth also, or you can take it to the USB module. But if you are using in the mobiles, then you have no other option. Either you can take it on the WhatsApp or some kind of data transfer like you can take through Wi-Fi and other Android applications also. So in this classification of chest diseases, there are different topics that you will find in the papers that the people are working on. Lung segmentation is also a separate part in which many research papers have published. Locating the abnormalities inside the heart, like designing this bounding box, that exactly where this, why this X-ray is called as normal or why this X-ray is called as pneumonia. So actually using some computer vision techniques, we can locate that at which part of the chest X-ray the signs of the abnormalities are available. So this is also a point of research. Many papers have been published as such. And using the machine learning techniques, we can basically do not locate also, we can directly classify for the different, for identifying the different chest diseases. So these are the three different topics that has been more studied in this complete domain. So these are some few works that has been reported in the literature, like one of the authors have done only for the pneumonia detection. So as you can see, the domain of AI is very huge. What people are doing, if they are getting the best accuracy on a binary classification or more than 2, 3. So based on that, they are performing the experiments. Like you can see, there are Praveen and Stick has done the classification for 5 classes. Wang and Wong has done for 5 classes. And some of the authors, they are selecting n number of classes, and whatever they find the best accuracy on that, they are just reporting it. So it is better to have more number of data while performing the experiments. In general, talking about the feature extraction and classification method, CNN has been more reported for classifying the diseases. In this work, 1,251 images considering the 4 classes has been classified, and different research in this YOLO and darknet model, the authors have used these models to locate the abnormalities inside the hearts. So many of the papers have also reported the tuberculosis classification. India is one of the leading nations that has been found more number of tuberculosis cases. So directly coming to the how we can make our model more efficient, or how we can just automate our this theory, that what are the different number of steps. So the 4 steps what we have discussed, these are the basics. If you want to, in many papers you will find that one of the, like you can also go for pre-processing, you cannot go, you should not go for segmentation. Many people, what they have done, they have gathered the data and they have directly applied to CNN. They have not considered the pre-processing part, which is more essential. In the real-time experiments, they have also not done the automatic segmentation. So what will happen, that if you are not doing the segmentation, you are extracting the false data, or the data we do not require. You are actually providing it to the training model. So the different stages involved in the detection of lung diseases are as follows: the pre-processing, automatic segmentation. I have divided the training and testing part, means I have employed the CNN model. So what I have done in my work is I have divided the training and testing part in 2 phases. In the first phase, I am only classifying the normal and abnormal cases. And then after, I am retraining the different kind of abnormalities to have more accuracy. And then after, I am testing the model. And finally, I have also developed a software and an Android application, a hardware device also for the same. So the input chest X-rays I have taken from the open source database, which is the NIH or the Kaggle dataset, followed by the pre-processing stage, where I am filtering or enhancing the quality of the chest X-rays, followed by the automatic segmentation, training and testing using the deep learning method. So in this stage, we are basically just differentiating the abnormal and normal cases due to the fact that the government of India or any of the agency or any of the nations, mainly if they want to approve your this kind of any kind of AI model, they want the specificity of the AI model should be very high. The specificity, the term specificity means the detection of the normal people must be high. It should not be a case that a person who is not having any kind of disease, and when their input is given to the model, then your model gives the false positive result. So the quantity of false positive results must be almost negligible. For example, if a person is suffering from COVID, not having COVID, having some kind of fever or any symptoms similar to COVID but not having COVID, if he or she is misidentified as COVID, so he is getting the treatment of all as all what the COVID patients are having. So this is kind of a mistreatment to the people. So the different medical agencies focus that the specific, at least the specificity of the AI model must be very high or almost negligible. The reason behind the RT-PCRs in the cases of COVID, the use of COVID, was the specificity of the RT-PCRs were almost 100%. In literature, it is 99 to 100%, but it was almost accurate. Means the ratio of identifying the normal patient was accurate. However, its sensitivity towards identifying the disease was varying about 65 to 80%. So while developing any kind of AI model, we must fix to a point that we should not give a false result to a normal patient, which is called as false positive. So in this training and testing using the DL method, we have first of all, we have considered all these number of diseases, or you can say the abnormalities inside the chest. But in this case, we have just first of all made two clusters, one for abnormal and second for the normal and abnormal cases. While we found that the accuracy of the normal and abnormal cases is very high, around 98 or 97%, then after we have gone for the second or the retraining of the DL model towards the identification of the disease. And finally, we have tested the models considering all the 14 to 15 number of different kind of abnormalities inside the chest, and which is displayed on the either on the software. You can generate the instant result also. So the key or the essential step is the pre-processing. The primary task of pre-processing is the quality improvement of the chest X-rays. This pre-processing stages has certain parameters like signal to noise ratio. So we basically aim to increase the signal to noise ratio using some of the filters, and we want to enhance the visual appearance by removing the irrelevant noise and undesired parts of the background. So the most commonly encounter different types of noises that are available in the chest X-rays are salt and pepper noise, Gaussian and Poisson noises. So taking account of all these different kind of noises, it is better you can use, first of all, you must identify the different, means while reception of data, it is quite obvious that input image will be associated with some kind of noise. But after identifying the noise, we can use different kind of filters. The database which we have considered is associated with such noises, and I have used the median filter because its performance on the predefined database is better. But let me remind you, it is not obvious that it will perform better or we will get a better result on some other chest X-rays. Suppose we are collecting the data from the other chest X-ray machines, it may be a possibility that the X-ray may be associated with some other kind of noises. So considering only these noises, we have used the median filter to basically suppress the amount of noise in the image or to enhance the quality of the image. These variables that are measured at the different scale do not contribute equally to the fitting model, and model learn function and might end up with creating a bias. So if we are not eliminating the noise, like in most of the papers while processing the chest X-rays, you will find that they have not used the pre-processing method. So if we are not doing it, we are actually enhancing our, or we are just boosting our AI model for a biasness, because most of the variables or signs may not be visibly clear for processing using machines, which is later processed by AI. One may have an imaging data set with great features, but if you forget to normalize one of those features, might completely dominate the others. So if the features are not very clear in the image, we will end up with I am directly calling it that its final output will be in terms of a false positive. So, and standardization of a data is also a part of the pre-processing. So we can divide the complete matrix using some mean, or we can subtract it. It depends on the values. We have to look at the values. What is the value, means the pixels, the value of pixels is there in the matrix. So it is a popular technique that subtracts the mean from values and divides by a standard deviation, transforming the probability distribution for a input variable to a standard Gaussian. Standardization can become skewed or biased if the input variable contains the outlier values. Apart from the noise suppression, during the medical image processing, the contrast enhancement is required for the area of interest. So this contrast enhancement is to improve more on the quality of images and make your region of interest more visible. Because in many of the chest X-rays, if the machines are not good, it is very difficult to identify the different signs. Like in this case, we can see that the picture is very clear. It is obtained from a different uh, system. But in this case, in the pneumothorax case, you can see that the image is covered with some kind of white patches over the entire image. It is complete white. So having such images, it is very difficult to diagnose the chest X-rays. So we can do the contrast enhancement in the chest X-rays using the contrast limited adaptive histogram equalization technique. So this is the Python code, as you can see, for the median filter or the mean filters also. We can use it. It depends on the data which will give you a better result. Talking about this method, it is used for contrast amplification in the vicinity of a given pixel value by the slope of the transformation function. This is proportional to the slope of the neighborhood cumulative distribution function, and therefore to give the value of the histogram at that pixel value. This limits the slope of the cumulative distribution function and therefore of the transformation function. We can also clip, we can also do n number of things if we face some problems, some more different kind of problems. Some more different kind of problems can be that different machines may have different sizes of chest X-rays. So you have to fix the different sizes of chest X-rays to a particular value. So this all fixing the size, enhancing, contrast enhancement falls in the pre-processing of the chest X-rays. So different more methods are also there. These are the results that we can see that we have got after applying two of the different techniques. This is the original chest X-rays, and below we have found out the after means application of these methods, we have found out the more clarity in the chest X-ray images. These are the codes, the Python code for obtaining these results, followed by the chest segmentation. Any of the segmentation in the magical image processing is only related to extracting the region of interest. And very clearly in this study, we are having the spinal, we are having the bones, but they are not of our interest. Our interest is only the lungs part. So we want to basically take out the left lung and the right lung out of this chest X-rays. So there are basically two different kind of approaches for image segmentation: the discontinuity based approach and the similarity based approach. In the discontinuity based approach, we basically focus on detecting the lines and the edges of the region of interest. And in the similarity based approach, we actually monitor the pixel value, and based on the variation in the value of pixels in the image, we basically identify the separation of the regions. Means that is from the lungs, from the chest X-rays. Since the lung segmentation is based on the geometric features like edges, segmenting the lung and edge detection is a fundamental and essential pre-processing step, because edges represent important contour features within the corresponding image. And then after we apply the thresholding. The thresholding is one of the similarity based approaches. There are different kind of thresholding techniques. The best one is the adaptive thresholding. We have to choose a best value or the optimal value in that case. And in the case of chest X-ray images, the thresholding, the dark object except the image boundaries means the lungs part, and the others are its background. So this, by choosing the threshold, we are basically the removing the background part and we are just extracting the lungs part. However, there are ready-made techniques also. These are the basic techniques. For the threshold segmentation, the another technique is the Otsu method. And here also you have to define a global threshold for finally differentiating the lungs from the chest X-rays. And based on the thresholding, we basically extract the outliers of the lungs. So lungs boundaries are extracted, and these are the results that we have considered a pre-processed image, and we have converted a bad quality image into a high quality. And then after, we are just highlighting only the region of interest, and just we are extracting the lungs out of this. These are the different results also. We are making actually the boundary box as we have discussed in earlier regarding the segmentation. This is based on the YOLO model. It is a pre-trained model that you can run on your chest X-rays. You don't have to develop some kind of algorithm, and you will directly get the results. They will locate the lungs on the chest X-rays, and then after we can extract the lungs out of the chest X-ray. In the third stage, means followed by the pre-processing and the followed by segmentation. The third stage is the feature extraction, and the fourth was the classification part. In the CNN, we will cover both the feature extraction and the classification part. So a convolutional neural network is a deep learning algorithm which takes an input image, assign the importance regarding the learnable weights and biases to various objects in the image to differentiate from one to the other. There are a lot of architectures in the convolutional neural networks. So the architecture of a CoVNet is analogous to that of the connectivity pattern of the neurons in the human brain and is inspired by organization of the visual cortex. Individual neurons respond to stimuli only in a restricted region of the visual field known as the receptive field. A convolutional network is able to successfully capture the spatial and temporal dependencies in an image through the application of relevant filters. So these are the 3x3 matrix which runs on the entire image. This one, I hope my mouse is moving. So that the architecture, this is the basic model in deep learning for image processing, used for learning the machines. So the architecture performs a better fitting to the image data set due to the reduction in the number of parameters involved and reusability of weights. The role of the convolutional network is to reduce the images into a form which is simpler to process without using features, which is critical for getting a good prediction. So in the architecture of the convolutional neural networks, I hope I am having some image. So this is the basic architecture of the convolutional neural network. This first one is the input layer, followed by the convolutional layer, output layer, max pooling layer, flattened layer, fully collected layer, and finally we get the output using the softmax, means the outermost layer of the CNN. So we can have, so this is the complete architecture of a convolutional neural network. So up to this part, up to the flattened layer, we basically extract the features of an image using filters and the activation functions. So we will see one by one what is the significance of these layers and what they actually do. So the filter moves to the right. So this is basically an image of the input, X-ray input, in which we have different numbers. These are nothing but the value of pixels of that image. So the pixels move, the filter moves to the right with a certain stride value that till it passes the complete width. So basically a small filter of such kind, 3x3 matrix, that is being rotated on the entire image. Moving on, it hops down to the beginning left on the image with the same stride value and repeats the process until the entire image is transferred. The objective of the convolution operation is to extract the high-level features such as edges from the input image. Convolutional networks need to be limited to only one convolutional layer. Conventionally, the first convolutional layer is responsible for capturing the low-level features such as edges, color, gradient orientation, and etc. So this is an image in which a kernel is being rotated. So it is a convolution operation that is being performed for M into N matrix using a 3x3 kernel. With added layers, the architecture adapts to the high-level features as well, giving us a network which has the wholesome understanding of images in the dataset. And there are two types of results to the operation. One is the convolved feature that is used to reduce the dimensionality as compared to the input. And the other is which the dimensionality is either increased or the same. This is done by applying the valid padding in the case of the former or the same padding in the case of later. So when we augment such kernels, that depends on the user. You can go for 5x5 or you can go for 3x3. So any kind of padding, if you want to use, you can use. This is a user defined, the size of the filter is basically the user defined. Similar to the convolutional layer, the pooling layer is responsible for reducing the spatial size of the convolved feature. This is to decrease the computational power required to process the data through dimensionality reduction. Furthermore, it is useful for extracting the dominant features, which are rotational and positional invariant, thus maintaining the process of effectively training the model. So there are two types of pooling, the max pooling and the average pooling. Max pooling returns the maximum value from the portion of the image covered by the kernel. And on the other hand, average pooling returns the average of all the values from the portion of image covered by the kernel. So basically it is suggested to go for average pooling. As such, all the values are being averaged. So if there is some kind of noise or some kind of other outliers that are associated in the form of pixel value, so they get actually minimized. However, you have to perform the experiment to see whether which is performing well. Max pooling will also performs as the noise suppressant. It discards the noisy activations altogether and also performs the denoising along with a dimensionality reduction. On the other hand, average pooling simply performs the dimensionality reduction as a noise suppressing mechanism. Hence, we can say that max pooling performs a lot of better than the average pooling. But as I have said, in my case, what I have done in my experiments, average pooling has performed well in comparison to the max pooling. So it depends on the data set which you are using, and you have to look whether after using which technique you are getting the better results. The convolutional layer and pooling layer together forms the ith layer of the convolutional neural network. And depending on the complexity of the images, the number of such layers can be increased for capturing the lower level of features. But on the other hand, we are actually also increasing the computational load of the algorithm. If we are designing a more complex architecture, the response time will be more. So finally, the flattened layer, which is the output layer of our architecture, is fed to a regular neural network for the classification purpose. So as I have said, up to this part, we can do the feature extraction part. However, there are other techniques also. We can use the transform domain of techniques, like we can go for FFT, we can go for fast Fourier transform, discrete cosine transform, Hadamard's transform, Wahl's transform. There are a lot of techniques that are available for feature extraction. So one can use any of them and can check the accuracy on any data set. And finally, in this case, we have classified using the output layer, using the CNN, but we have also other options also. We can go for the support vector machines. We can go for the artificial neural networks, or a lot of KNN classifiers are there. So a lot of machine learning techniques are also available. So what the researchers do actually, they actually basically play with the feature extraction and the classification algorithm. What they will do, either they will change the output layer and they will connect it to a SVM model. So they will extract the convolutional features from the convolutional network, and they will actually change the output layer with some other machine learning techniques, and they are actually publishing. Or they will change the feature extraction part. They will apply some kind of transform, or n number of feature extraction algorithms are there. So they will use them and just classify using the convolutional neural network. Secondly, what they actually do for selecting this means the internal parameters of this classifier are chosen manually. So you have to regularly vary them and monitor that what is the accuracy for that particular value of the internal parameter. So another option of manual selection, or the other solution other than the manual selection, is the uses of the optimization techniques like particle swarm optimization, genetic algorithms. Using those methods also, you can select the internal parameters of the classifiers. They will give you the optimal parameters and lead to the best accuracy. However, it is going to again increase the computational load of your method. So generally, researchers focus on two things for either getting a PhD or for either publishing papers. The first one is the accuracy, how much accurate your AI model is. And the second is the computational complexity of the methods. If you are capable of developing an algorithm which is less computational complex, or computational complexity means the number of operations in form of additions or multiplications. So if the number of operations in your algorithm is less, or the execution time of the algorithm is less than the existing methods, then you can easily get a paper. So finally, we are moving towards how we should present the results. So the images are, as I have said, taken from the NIH chest X-ray database. Considering the 3 classes, we have taken all the classes also. Means we have tested n number of methods on n number of classes. And we subdivide the data set into 2 parts, the training phase and the testing phase. In the method, you can split using either 70-30 or 80-20 it doesn't matter, but you should train your model on more number of chest X-ray data set. And finally, you should do a cross-validation technique. This is a very essential step in the cross-validation. It avoids the biasing of the classifier. Means you can say that there will be less number of either false positive or false negative. So k-fold cross-validation technique must be applied. So under this technique, means after during training and testing. So what happens is, if you are going for 5-fold or 10-fold or n-fold validation or k-fold, so on k-1 splits, we are going to train the algorithm, and for the one split or the one part of the training set, we are actually testing the method. And this is repeated for all the subsets. So in the 5-fold, as you can see, you can also go for the 10-fold, but just make sure that this cross-validation you are doing, because it will give you a valid result. There may be a possibility that your AI accuracy is 99%, 98%, but while you will give a data from outside on a from a similar machine, then it will end up with a bad accuracy. So performing this cross-validation technique will give you a valid result. It will not give you a result in which you will find that you are getting 99% accuracy. But if you are taking the data from outside or from some other method, you are just getting a poor accuracy in the testing phase. So in the 5-fold validation, the 4 folds are used for the training purpose and 1 for the testing purpose. And similarly, each fold of the 5 folds is tested of 5 times, and finally the accuracy achieved at each fold is basically averaged to have a valid result. In this case, the sizes of images which we have taken was 256 by 256. You can also go for a high range of image size. You can go for 512 cross 512 or 1024 cross 1024. But just make sure that you are increasing the you are actually increasing the memory of the system. So a lot of memory requirement will be there if you are increasing the size of the image. Obviously, increasing of size of the image will give you a better result or more valid result. But to train such large number of data or large number of images, we have to have a good server or some kind of GPU based servers are there. So as I have said initially, a basic model is trained to separate the normal and the abnormal chest X-rays. And then after using the transfer learning approach model, we have just subclassified the diseased images into different categories. These are the different parameters that are being used in the convolutional neural network. And these are the results, as we can see. These are the precision and the ROC precision recall curve. On the x-axis, we can see the recall. On the y-axis, we can see the precision. So it is almost, we can say these are the different kind of CNN architectures. So due to the time limitations, I have not discussed what are the different what are the different kind of CNN networks and what they have the advantages or the disadvantages. But just for the knowledge purpose, ResNet 18, ResNet 50, FuseNet, DenseNet, MobileNet, there are many number of I think almost 15 number of CNN architectures that are available. You can just train and test them one by one. And as we can see, the ResNet 50 architecture of the CNN or the ResNet 50 has reported the best precision and recall curve on the left hand image, and on the right side we can see that on the right side also we can see that the accuracy reported by the ResNet 50 for the true positive and the false positive rate is quite high. It is around 99%. So true positive is the total number of correctly classified images into a particular category. I hope I am having some kind of, yeah. So these are the simulation results, and this is actually the result from which we find the accuracy. It is called as the confusion matrix. In this figure, we can see that there are three classes, 0, 1, 2, and we can see that the diagonal elements are called as the true positive rate. So this is the first category, and the total number of 80, 75 plus 5. Out of 80 images of a particular category, say as normal image, out of 80, 75%, 75 images are correctly classified as normal, and 5 are classified as COVID-19. In the second row, we can see that the total number of images considered in the testing is 388 plus 17, which is around 405. And out of 405 images, COVID images, none of them has been identified as normal. Out of 405, 388 are correctly classified as COVID-19, and 17 are classified as pneumonia. Out of 96 images, none of them are classified as normal. 4 of them are classified as COVID-19. So basically it was the symptoms. It can be interpreted as these images have a sign that is more related to a COVID-19 images. So this has been falsely detected by our algorithm. And out of 96, 92 has been considered, means correctly classified in the pneumonia case. So false positive means total number of misclassified events into a desired class. Simply, it means that if a person was normal and if it has been identified as abnormal, like in this case, the number 5 of the patients has been termed as the false positive. False negative means total number of the misclassified events of a particular class. And true negative is the total number of classified or misclassified events of the other classes. So sensitivity and specificity are calculated on the basis of these 4 parameters. So sensitivity is defined as the ratio of true positive by the ratio of true positive and true positive plus false negative. And specificity is defined as true negative by true negative plus false positive. So sensitivity is simply, in a layman language, it is defined as the number of or the ratio of classifying the diseased cases. And a specificity means, for example, if 100 of the persons are diseased, and out of 100 diseased patients, if we are correctly classifying 80 or we are correctly detecting 80 patients, then we have a 80% of sensitivity. talking in terms of specificity, if we are having 100 number of normal patients and we are correctly detecting the 95% patients, then we say that 95% specificity of the AI model is. So it is better to have a highest specificity because it is the guidelines of the government also, and it is more towards the manual intervention. So some of the experiments were extended and validated at AIIMS Patna and RML New Delhi, and we have taken the samples from there. So on the sample data set, we have achieved almost in the first phase, we have achieved a 92% sensitivity and specificity of 94%. While at RML New Delhi, we have found the specificity around 90% and sensitivity of the same model around 95%. So you can actually see by visualizing these two results that there is variation of the same model on two different data sets or two different, means the data from two different organizations. Again, we we just develop our model more accurate, and finally we end up with a end-to-end software. We use a GUI based platform. We have developed the exe file. After double clicking on the exe file, the GUI based pops up, opens up and asks for the OTP. It is developed on end-to-end in the Python environment. The proposed software is focused on the general purpose computer. It can simply run on 4 GB and 4 GB RAM and i3 processor. The proposed software is efficient in terms of accuracy and computational complexity. And we have also made a provision that after the results are basically received on the mobile phones and a report is generated in a PDF copy in this form. On the left hand side, this is the platform of our software, what we have developed. We have filed the patents also for the same. And you can upload your images, and you can see that there are 3 buttons: upload chest x-ray, get result, and submit. You have to fill all the fields. Only the patient ID is automatically generated. And if some of the doctors or some of the experts or the lower medical officers, if they want to give some comment on the results, they can also manually type them, and after clicking on the submit button, you will get the result on the mobile phone on the right hand side with a date, time, and whatever the format of the message you want to get, you can just program it. And a PDF is also generated after clicking on the submit button. It will automatically go to your email, whatever email and phone number you have given here. So in this format, the mail comes, and this is the format of the PDF that is being automatically generated by this platform. You can also go for mass screening. In this case, we have developed for 1-by-1 classification of the chest x-rays, while in this case, we have just given 5,000 images at a time or 1,000 images at a time. And within 5 to 6 minutes, I think we have classified 1,008 images of chest x-rays. We have also developed the same model on the microcontroller platform using a 7-inch touchscreen LCD. The input x-rays are taken through the pen drive and processed in a similar fashion as we have discussed. This device is battery operated. This is basically the prototype. We have developed it on the Raspberry Pi microcontroller platform. For the demonstration purpose, the final PCB fabrication has not been done yet. But this is a platform that is being developed on a similar manner what we are doing in the software part. And Android application is also developed. it is such technologies are very advantageous to the humankind, because in the case of COVID-19, there was a manual there where the chances of manual errors while collecting the data. That collection of data was also a tedious task. We have to visit the hospitals, and its accuracy regarding the manual due to the manual error was also less. So sensitivity, specificity are the major concerns. The cost is that can be decided by you only if you are the developer. The basic advantage you will find here is regarding the time, regarding the clinical setting. It does not require any kind of specialized laboratory, as we have seen in the case of RT-PCRs or the PCRs technology also. The technical description, it is the AI-based technology, while all the other tests are the biological tests that we have seen in the case of COVID-19. And handling a person of basic knowledge of the computer can, just a layman can use such technology using AI, and a report is being sent on the mobile and email, as we have discussed. So such kind of fabrication can be done using the PCB based device, and these are the publications till now what we have done. Its future can be to use the to increase the more number of diseases by processing the chest x-rays, to develop more efficient algorithms to achieve higher accuracy, and the most important one, we can integrate the same platform with the x-ray machines. So that's all from my side. If you are having any questions, you please ask. I am open for the questions if you are having any.
Please, if you are having any question, ask them, sir.
Sir, can I ask one question, sir?
Yeah, please.
Actually,
Go
sir,
for
I'm
it.
just asking if someone is doing research and if medical data is not available. So, how generative AI can help them to get those data sets?
Sir, as I have clearly said, the most important thing in AI is the data. If you are not having the data, for example, what problems I have faced regarding my research, in India, we have no publicly available data set.
Yeah.
No data set is publicly available of any disease. Either it is a chest x-ray or related to heart or malaria or any. So I am sorry to say that without data, you cannot do anything. You have to visit hospitals for the data, at least in India. If the data set is publicly available, then it is no problem. Many of the data sets from the foreign countries are publicly available. But without data, you cannot proceed in the domain of AI.
Yeah, right. But sir, if we have to publish some paper, and in that case, if few data are available, so can we generate few more? I am talking about that in that sense.
Yeah, there is a technique to replicate the data, but it is obviously better to have or to collect more number of data. There are techniques, some of the techniques like image augmentation techniques are there to balance the different, there are many kind of problems, but due to the shortage of time that I have not discussed. Just I have gone for an end-to-end product or end-to-end kind of a solution for a particular problem. But for doing the research, techniques are there. If you don't have data and you have to do the work, then you can go for the augmentation techniques also. There are a lot of techniques that replicate data, but the most important thing is data is the variability. How much different variety of data you have. Because suppose there are 10 varieties of data and you have only 9, and you are trying to develop some kind of solution for the people. then what is going to happen is, while you are deploying such solution in the market, and if you are encountering with the 10th type of data, then your complete solution is going to fail. So for publishing papers, it is enough to have a lesser number of data, but for a complete end-to-end solution, you should go for the collection of more number of data. You should contact the hospitals for the same.
Okay, sir. And how, sir, you have mitigated the class imbalance problem? Because obviously, if you have a same number of classes in our data set, so it will discriminate once we finish the AI model.
See,
So how
there are different kinds of technique, right? That are being used in a like what I have did is, first of all, I have balanced the data set. So for balancing the data set, as you may see that in the first part, what I have said is the normal and the abnormal. Obviously, the disease cases, the number of disease cases will be less than the normal cases. So first of all, I have made the complete abnormal into one. So in the abnormalities, there are 15 different kinds of other chest diseases. So in the initial stage during the training, we have balanced the data set using the data. Means we have taken the 50,000 for the normal cases and 50,000 for the abnormal cases, and we have done the augmentation to basically avoid, and followed by the cross validation technique to avoid the biasing of the classifier. Any more questions, please?
No, sir. Thank you so much for your answers.
So, okay. So I appreciate you taking the time, share your experience with us, sir. Your presentation on AI-assisted pulmonary disease detection was really educational. You informed us of the methods used by MRI and CT scans to identify abnormalities in the lungs, heart, and chest. Understanding how the classification of chest abnormalities is done was made much easier with the chest X-ray images. You tell us the objective and the key stages of processing chest X-rays, which include pre-processing, segmentation, feature extraction, and finally classification on the basis of ML and DL techniques. The addition of case studies to your explanation definitely made it easier to understand. A detailed explanation of the stages involved in lung disease detection, what are the basic approaches for chest image segmentation. You propose a basic architecture of the convolution neural network and show the participant gained enough knowledge from your extensive yet clearly presented details in your presentation. Again, sir, I want to express my gratitude for all have done for this STC. Thank you.
Thank you, sir. Thank you for this opportunity. Thank you. Thank you all, the participants also. Thank you for having patience to listen me. Thank you.
Okay, so thank you everyone. By tomorrow, I told you that we are trying to conduct one quiz and you need to also give feedback to us. So okay, you all may leave it by email or in WhatsApp. We are going to share you all details. Okay, thank you. You all may leave it. Thank you for the discussion.